Now I request Professor D.D. Bihola, sir, Department of Botany, to welcome Professor Y.N. Patel, sir, Head of the Department of Chemistry, with bouquet. I request Dr. Arvind Suthar, sir, Chemistry Department, to welcome our convener of the conference, Dr. Suresh Kumar, sir, with bouquet. We have with us our invited speakers, so I request Professor Sangeeta Madam to welcome them with bouquet. Dr. Neeraj Gupta, sir. Dr. Vasi, sir. Thank you. We have with us our judges, so I request Dr. Poonam Wadhwani ma'am to welcome them. Dr. Pranav Srivastav. Dr. P.J. Vyasa, sir. Dr. A.S. Prajapati, sir. Dr. Y.S. Patel, sir. Dr. M.K. Thakur, sir. Dr. Jagdish Bhai Prajapati, sir. Dr. G.D. Acharya, sir. Dr. K.M. Joshi, sir. Dr. Kalpesh Goswami, sir. Dr. Umesh Tarpada, sir. Dr. U.R. Patel, sir.
Former Professor of Chemistry Department, Viral Bin Patel.
Vimla
Vimla Bin Patel. Sorry, Vimla Bin Patel. Thank you. Now we request our principal, sir, Dr. R.D. Mode, to welcome our esteemed guests.
I feel great honor to welcome our chief guest for the event, Honorable Dr. J.J. Vora, sir, Vice Chancellor of North Gujarat University, Patan, who took out their valuable time to honor us with their dignified presence. Today I got opportunity to say something about MN College, Visngr, on this occasion. Today, on the occasion of International Conference on Recent Progresses in Chemical Sciences, I heartily welcome all the dignitaries, experts, research scholars, participants, and everyone present here to MN College, an institution having earned an exceptional place in the education of world of the North Gujarat. Today, the institution is adding one more feather to its reputation by organizing an international conference, which is a rare event in itself in the sense that it may be the first college among 110 government colleges to organize such an event. It is a matter of immense pride that various scholarly personalities like Jnanpith Award winner Sri V.K. Gokar, poet Armando Manzis, mathematician Sri P.C. Vaidya, and many more have devotedly served the institution to establish the reputation in all directions and founded the path of progress for futures. With their best efforts, MN College has given the society, the nation, such great personality like Honorable Prime Minister Sri Narendra Bhai Modi, former Chief Minister and present Governor of Uttar Pradesh Sri Anandiben Patel, former Chief Minister Sri Shankar Siji Waghela, former Union Minister of State late Sri B.K. Gadvi, Jnanpith Award winner Sri Raghuveer Chaudhary, former Minister Sri Ishwar Singh Chavda, writers, IAS, IPS, scientists, industrialists, artists, and many more. As I joined my duty as the principal of the institution having unparalleled heritage, I got energized to impart my contribution to the institution. At that time, the staff was diligently preparing for the NAC accreditation in 2019. The college received B double plus grade with 2.97, ranking first among the all 110 government colleges. After NAC accreditation, which became a milestone in the development of the college and has continued to take the consolidated strides. In MN College, the Center of Babasaheb Ambedkar Open University and IGNOU have been started. A number of activities and schemes like Saptadhara, Finishing School, Odisha, MYSY scheme, Ek Bharat, Shrestha Bharat are successfully running with maximum outputs. As MN College has a very large green campus of 37 acres. It has received an award from the MHRD for its green audit. Under the student startup policy 1.0, the college got rupees 80 lakhs grant for the proposed project and become the one of the highest grantee institution in the entire state. In the year 2019-20, MN College was permitted to offer psychology as the principal subject after getting the approval as a new matter in the budget of the year 2020-21 for two new main subjects, psychology, sociology, and BSc Computer Science. And from the year 2022, the institution started to offer the subject with specialization. The college has also started a new PG courses like MSc in Physical Chemistry, MA in Sociology, and MA in English this year. Laboratory equipments worth rupees 30 lakhs have been procured through KCG and rupees 2 crore grant received from the RUSA. The institution acted as a nodal college for the placement here in since 2020-21. It is also a nodal college for many state government and university initiatives like Innovation Club, Vaccination, G3Q quiz, exam centers, and many more. Thus, MN College Visngr has been steadily progressing. The college has witnessed continuous growth through its extensive run. The proposal of the new matter made by the college in the budget of the year 2020-21 has been approved by the State Education Department, and a grant of rupees 31.25 crore has been sanctioned to the college for erecting a new science building. Also, for the building a new seminar hall, a grant of rupees 2.87 crore has been approved. The foundation stone for both of them has been recently laid by former Chief Minister and present Governor of Uttar Pradesh, Sri Anandiben Patel. Apart from this, MN College Visngr has been recognized as a heritage building by the Education Department of the state and sanctioned a grant of rupees 2.38 crore in the year 2020-21 and rupees 0.79 crore in the year 2021-22. As per the proposal of the college for the renovation of heritage building. Moreover, as the college completed 75 years in the year 2020-21, the college decided to celebrate Amrit Mahotsav in a grand manner. Due to the tireless effort of MLA Visngr and Health Minister Hrishikesh Patel, the college has received a grant of rupees 1.85 crore from the Chief Minister Fund, which is again the special case for the institution. In all respects, the institution is sparkling star which has been witnessed unprecedented progress and will continue to achieve milestone in future as you are also the witness of the same. For that, I am highly indebted to all of you to be present on the gleaming occasion. Thank you, Lord. Thank you, Lord, all of you. Thank you. Vande Mataram. Jai Hind.
Thank you, our principal, sir, Dr. R.D. Mode. Now I request the convener of the conference, Dr. Suresh Thakur, sir, to enlighten us about the purpose of this conference. Sir.
Our chief guest, Dr. J.J. Vora, HNU Patan Vice Chancellor, our IQAC coordinator, and organizing secretary, Dr. Y.M. Patel, head of the department, Professor Y.M. Patel, guests, dear participants, MN College staff, delegates, and volunteers. On behalf of organizing committee, I welcome you all to the two-day international conference, Recent Progresses in Chemical Sciences. I'm pleased to share you that this is the first international conference organized by MN College Visngr, inspired by the late Dr. Ashaben Patel, who have organized a national level conference in year 2017 under the leadership of Dr. K.M. Joshi. In this conference, we have overwhelming response from the participants. We have more than 200 participants online and offline joining with us. There are 8 online and offline speakers. 5 speakers are offline and 3 speakers are online. The theme of the conference is Recent Progresses in Chemical Sciences. The theme was chosen as, you know, chemistry is the life. It is the essence of life. There are atoms and molecules only. So chemistry in all sphere is involved. It joins all the sciences, all the branches of science. And at the same time, you know, in the recent time, we have seen the unmatched role of chemistry in the COVID-19 pandemic, where we have developed potent vaccines with the help of the knowledge of chemistry. This conference will highlight the recent trends in chemistry and the related areas by using an interdisciplinary approach. I hope that by the end of this conference, all of us will have broadened our knowledge about the recent trends in chemistry research and related areas. This conference will also provide an opportunity for the young researchers to interact with their peers and collaborate with them across the country and the world. This also opens the scope for effective collaboration to achieve the research goals constructively. With this, I wish you all the best. Thank you.
Thank you, sir. Today, our chief guest is Honorable Vice Chancellor of HNU, Dr. J.J. Vora, sir. Dr. Vora is the former head of the Department of Chemistry, HNU. He has a specialization in organic and analytical chemistry. His areas of interest are coordination, water quality, photochemistry, and kinetics. Now I invite our Honorable Vice Chancellor, Dr. J.J. Vora, sir, to the podium to say a few words.
How much time?
This is for online.
Mm-hmm.
A very good morning to all of you. The organizers, Principal Dr. R.D. Moore, and the team, enthusiastic team of various heads and teachers of departments. First of all, I congratulate all of you for this beautiful organization. When it is the matter of recent progress, we have to go through what is going on in the field of various science areas. If we recollect, the chemistry Nobel Prize was awarded for this year to three scientists who work independently. One is Dr. Sharpless, the other Dr. Meldal, and Madam Dr. Bartosi. Their main area was click chemistry. Now, the word click, see, science and literature, they both have to go together so that it will reflect something which is very clear. When it is said that click chemistry means, if you recollect, when we make use of car belt, seat belt, when we join the two, they will join, and there will be a small uh, noise with click type of sound. The chemical reaction is also somewhat similar. The reaction, as we may recollect, alkyne and azide. Azide, as we know, it is an explosive material, but when you permit it to combine with alkynes, will give a number of products, and the percentage yield will be very much less for all. So it is difficult to control the reaction, where to go. But when you make use of cuprocyan as catalyst, the results were wonderful. Only one product that was found in major proportion, and this product uh, is a derivative of triazine, 1,2,3-triazine. Now, what is important? These are important biomolecules, and you can prepare a number of types of biomolecules with this click reaction. There are as such 4 types of click reactions. So we are not going into that detail, but what is important, that he was working, Sharpless and Meldal, both of them independently carried out the research and reported independently. Of course, they were conversant with what others were doing, but they were successful in this endeavor using cuprocyan as catalyst. Now, these two scientists, they were working since 1996, and Sharpless is the only person living right now who has received 2 times Nobel Prize. So we can understand the consistent work of the great Nobel laureate Sharpless, and he was successful in getting the yield he desired, and a number of biomolecules of significance were produced. Now, the third scientist, lady scientist who was working, but she thought that uh, making use of cuprous ions, it will, when it is in larger amount, it will be a very toxic material. So, uh, when she tried to do it in absence of copper ions, she was not successful. But she attended one conference, such conference, international conference, and she heard another scientist who was working in a slight different way, and she realized that I could also make use of this thing. She made use of the technique that she learned in the conference, and she was successful. So without using copper ions, she successfully got the product she wanted, and actually she experimented on living cell, and that was successful. So bioorthogonal chemistry, she named those reactions were similar combination of azide and arine, and she gave the name bioorthogonal chemistry because she was successful in avoiding the use of copper ions, which is of course cytotoxic if we recollect. So this is how the significance of a conference you can imagine. When you attend a conference, please do make the notes, whatever. Suppose we are working in a field and similar kind of work, or maybe somewhat similar, 10%, 20%, 30%, whatever. So try to make a note of all the important ideas, and you may get some beautiful idea. That is very important. But it should be, research should be not to get a degree. Of course, getting a degree and later on for employment, everything is okay, but research is for pleasure. And when you uh, imagine something, see, imagination is a very important part in chemistry. If you recollect the example of structure of benzene, how that was established, the Kekule, he imagined a lot of things, how you could uh, establish the structure of benzene, because at that time it was not possible to get exact spectroscopy in order to get the structure. So he made a number of attempts, he imagined a lot, he worked out, and ultimately his imagination resulted in the correct structure of benzene. So imagination part is very important. You may recollect the other example of spin quantum number, Uhlenbeck and Gauss-Schmidt. Both were thinking electron as revolving uh, around the nucleus and also on their own axis, just like Earth moves around Sun and also on its own axis to make possible the day and night. So they thought that electron also must be carrying out the similar kind of motion. They wrote a paper. Imagine that was without any experimental evidence, but simple imagination. They thought that this must be occurring. They wrote the paper. They submitted it to the editor, already submitted, and they went on discussing. They submitted, the outcome was not there, but before the outcome, that is publication of the paper, came, they started discussion with a number of senior scientists, and they could not agree because there was no experimental evidence. It was difficult to agree with the concept of a rotation of electron along its own axis, because that time it was difficult to get a very sensitive instrument or spectrum. Say, for example, doublet of sodium, 539 nanometer, It was not possible at that time, around 1930s. But they were strong enough to give the paper. And when they went to the editor that we want to take back it, see what happened. They went to the editor to take back the paper that now we don't want to publish it because there is no experimental evidence. We discussed with a number of scientists and they also did not agree upon that thing. But the editor, see, when it is a senior person, that is the difference of experience. And an example of a very good researcher, he answered that at this young age, you are permitted to make a few blunders. Now, that was the answer of the senior editor who was a very good friend of Albert Einstein. And ultimately, that thing was proven experimentally. And when it was proven, they were recipient of Nobel Prize. So this is how imagination also works. So we have to imagine what it may be. And we have a very beautiful shloka. If you recollect, the shloka says that, see, again, the imagination part, I am talking about 1,000 years back, the authors were there. They imagined that, I am just telling the shloka, Asita तच्चले सिंधु पात्रे सुरतरोवर शाखा लेखिनी पत्र मुर्वी शारदा सर्वकाले तदपि तव गुणानामीश्वरम नयाति. So what exactly he wants to convey, that if you make use of sea water as your solvent, if you use sea water as your solvent, if you dissolve or make an ink using your mountains, making the use of mountains, and if you take a paper of the size of earth, if you take a paper of the size of earth and if you write down with kalp vruksh, and if Saraswati, not anybody else, Saraswati goes on writing, she will not be able to complete the good things about God. See, the part of imagination, the author has imagined sea water as a solvent and a mountain. If you make a mesh of it and dissolve or make a colloidal solution, whatever. So this is how imagination describes the good things about God. You cannot describe, it is endless. And this is what the important part of imagination in scientific research. A number of examples you will find. We have Dr. R.D. Mode, Dr. Jagdish Bhai, and a number of physics people. You can find a number of other examples of physics where imagination has played important part. Even in chemistry, you can find out a number of examples. We have Professor Srivastava with us, and he also will be able to tell various examples how imagination has helped the researchers in different parts of the world. Now, these are the recent developments, and biomolecules are of prime importance because, see, the recent example we experienced in the year 2020, where the corona epidemic and pandemic rather was there throughout the whole world, and our scientists, if you realize, they worked like anything day and night and prepared a very efficient vaccine in our own laboratory. And this is how the importance of research, and our own prime minister that time went to the laboratory to encourage to look at the situation, what is actually the current status of research in the field of vaccination. And they were uh, all very happy that the country's prime minister visited their laboratory to encourage them to see the progress of vaccination, where is it, and they were very successful. So this is the research why biomolecules, any endemic, any pandemic, anything can happen at any time, and we have to protect ourselves. We have to boost up our immune system, and thereby you can survive. Otherwise, if you go on the other way, it will be very difficult to survive. So these were one thing more I wanted, because youngsters are there. I was told that more than 200 youngsters have registered here. So when you are associated with various fields, various areas of research, there are a number of schemes available, and unfortunately, Nagarajan ji is not available today. Otherwise, he had a number of options to encourage research in whether you are a student of science, any science subject, or maybe arts or commerce, whatever, you can get a very good funding from government and you can utilize it. So money will not be your factor to restrict. So I think you can take help of a number of equipments available here, available with university departments, whether it is um, North Gujarat University, or even Sardar Patel, Baroda, and so on. You can have the access to a number of important equipments, and you can carry out your research very efficiently. But when it is matter of finance, the government is helping a lot, and you should take help of those funding whenever the money becomes your limitation. So these were the few words which I wanted. So when you make use of these things, you can become an entrepreneur, and I will quote one example. My habit at some of the students I can see here used to ask some of the questions in the classroom, and my bad habit or good habit, whatever you say, but habit was not to answer those questions and to tell the students to find out from any source they have. You are very fortunate right now that on your fingertips you can get the answer of a number of things, majority of things, but it was not the situation maybe 20 years back, 20, 25 years back. So I asked one question. Obviously, student did not have any answer that time. One of the students remembered the question, that this question was asked in the classroom. He got his MSc degree. He got his MSc degree and later on appeared for interview, and same question was asked. Then he rushed to our department. Sir, you were you ask this question in classroom, you did not answer, but now answer me, please, because it is asked in interviews. So again, I repeated the same thing, but I told him that you go on search for these three important sources and you will find the answer somewhere. And he went to the laboratory and so forth, so on and so forth. But what happened that his zeal for getting the answers from the right source resulted into his becoming an entrepreneur, and he is right now having a very good industrial organization with 60-70 crores turnover per annum. You can imagine that you have all the potential to become an entrepreneur rather than searching for 10,000, 20,000 job. So, with those words, I think whatever I wanted to express a few things to you should be that remember several points, and one point again would like to elaborate the same era Salve conference. You might not have, at least youngsters might not have heard what is Salve conference, but that was, I am talking about 1929, 1930 and so on. 28 Nobel laureates were present in such international conference, which was known as Salve conference. In this conference, you can see Albert Einstein, Max Planck, Niels Bohr, and so on, a number of scientists which were responsible in development of quantum science. I will not say quantum chemistry because we have a number of physics people here. They will say we also learn, we also teach quantum physics. Mathematics people will say we are also teaching quantum mathematics. So it is a subject which is very important. So I will term as quantum science. And you know the example of Rydberg. Rydberg gave the equation to explain the spectral lines, the difference in energy, but he was not aware about any molecular or any atomic system that time, but still he gave the equation. See the power of mathematics, you can realize that he gave the equation to explain those spectral lines. Then after, Niels Bohr gave his model, and he, when he matched the Rydberg and his theory prediction, and he gave very satisfactory explanation for hydrogen spectrum that time. But in that conference, remember, Albert Einstein was the person who, in a very lighter vein, used to criticize, not exactly criticize, but he used to uh, describe these things. That do you really think God plays with dice? ભગવાન પાસાઓ રમે છે આપણે એમ કે n is equal to 1, n is equal to 2, n is equal to 3. એટલે કે તમને એવું ખરેખર લાગે છે ભગવાન પાસાઓ રમે? So that were his words, how he understood the quantum chemistry. But later on, with all developments, all round developments, a number of sensitive equipments and a number of theories the quantum science developed. Still, there was one problem. The Schrodinger equation gave the solution for 3 quantum numbers, and one quantum number was still left, that was spin quantum number. As I said earlier, the spin quantum number suggested by Uhlenbeck and Gauss-Smith, that was not possible at that time with solution of Schrodinger equation. But again, Albert Einstein, when he gave relativity theory and relativistic Schrodinger equation was put up, the solution of this equation automatically gave the theoretical spin quantum number. So this is how the story goes on, and now we have a very drastic change in the structure of atom, quarks and top quarks and God particle and so on and so forth. So I am not an expert to describe this thing, but see, science is a regularly developing kind of the knowledge, and we have to be with the time. And we are fortunate right now that we have a number of experts who will be delivering their lectures in various subjects, and you will be a real beneficiary when you learn the different subjects by different experts. So, with these words, I once again congratulate Principal Dr. Mode and the whole team for organization of this beautiful conference. We have a number of delegates, speakers who are also present online right now, and I am sure that the deliberations will be very, very useful and life-changing for a number of delegates who are present here. So with these words, I once again thank and congratulate the organizers. Thank you.
Thank you, sir, for your enlightening words. Now I request Professor Y.M. Patel, sir, Head of the Department of Chemistry, to extend vote of thanks.
Namaskar. A warm and graceful morning to one and all present here. On behalf of Chemistry Department, MN College Visngr, I am glad to be standing here to propose vote of thanks and acknowledge the contribution of all who really worked hard to make this event successful. First of all, on behalf of all of us, let me thank God Almighty because only due to their grace and bless we are breathing here together at this present and pleasant moment. Thank God. A special thanks to our chief guest, Professor Dr. J.J. Vora sir, Vice Chancellor, M. Chandracharya, North Gujarat University, for accepting our invitation and being here with us today, in spite of his busy schedule, to grace this occasion. Sir, you have served Society of Chemistry for a long period of time by your thoughts, knowledge, research work, and administration too. We are truly inspired by you. Thank you, sir, once again for your stimulating and captivating words. We are sure that our participants are thoroughly motivated by your pulse of wisdom. Thank you, sir, once again. I extend my sincere gratitude to our principal, Dr. R.D. Mood, sir, for his inspiration, motivation, and guidance to organize such a big event. Thank you, sir. for your continuous and constant support in all our endeavors. I would like to thank our organizing secretary, Dr. Y.M. Patel, sir, as he is the backbone of our organizing committee. Thank you, sir, for your support at all stages of planning and preparation for this conference. Convener Dr. Suresh Kumar is the person who has taken care of each and everything related to this conference. He is totally involved since last 6 months in all the arrangement of for this conference. He has very precisely picked up our eminent invited speakers from various locations on this globe and make the conference of an international standard. Thank you, sir, for your wholehearted contribution. I would like to thank invited principals, head of the departments for different colleges, Dean of Science, Dr. Jagdishbhai Prajapati, our faculty members, committee, advisory committee members, and remain present in this occasion and will also provide their priceless services judges during offline and online oral and poster presentation. Thank you. I would like to thank our judges and our members of committee, Pranav Srivastav sir, for being here with us, Professor P.J. Vyas sir, Dr. Y.S. Patel sir, Dr. A.S. Prajapati sir, Dr. K.M. Joshi sir, M.K. Thakur sir, Dr. G.D. Acharya sir, Dr. U.R. Patel sir, Dr. U.P. Tarapdas sir, Dr. K.D. Goswami sir, Dr. G.R. Jani sir, and more members coming from different colleges. I would like to thank our eminent speakers, Dr. Pankaj Sharma sir, Dr. Sangeeta Ben Sharma, Dr. Vasi Sheikh sir, Dr. Satyendra Misra, Dr. Neeraj Gupta, Dr. Rakesh Pathak, Dr. Rakesh Dhiman, and Tushar Mehta sir for joining us online or offline mode by accepting our invitation. Our organizing committee is made up of some young, energetic, and enthusiastic members such as Dr. Poonam Vadwani, Dr. Sangeeta Sharma, Dr. Sangeeta Suthar, Dr. Arvind Suthar, Dr. Deepika, Dr. Rakesh Prajapati, Mayur Marodia, uh, Dr. Sejal Joshi, Dr. Mittal, Dr. Shakti Ramanandi, and we have also some senior professors in our committee as Dr. R.N. Bhausa, Dr. Kaltaben Machar, Dr. Gitaba Chawda. All of them have really worked hard, not only for day or two, but for last few weeks. Their constant and continuous contributions will make this event successful. I heartily thank you all my buddies. Further, I would like to thank our HODs, faculty members, visiting faculty, non-teaching staff, office staff, our IT and technical team, security, dear students, volunteers, sweepers, peons, and A to Z members of our MN family. Thank you. I am also thankful towards our vendors like BCL, Scientific, Purvi Enterprise, Umya Cells, Guru Krupa for their contribution and cooperation for this conference. Further, I extend my vote of thanks to our service providers and media partners for their coverage. Last but not least, you, our dear participants, without you, we are nothing. A lot of thank you to joining this conference and being here to make this occasion a grand success. We would like to thank all the known and unknown hands that contributed for the success of this program. Once again, I would like to thank each one of you. I am very grateful for giving me this opportunity. With sincere feelings of gratitude, I would like to take your leave. Be happy. Have a nice day. Thank you.
Thank you, sir. Now I request all the presented dignitaries to stand in honor of the Song of MN College. Now we shall assemble for tea break downstairs. We shall resume the sessions afterwards. Thank you.
Thank you.
પછી પેલા સરને આપી દેવું પડશે ને મારે ઇન્ટ્રોડક્શન પછી. Good morning, one and all. Welcome to the first technical session and of International Conference on Recent Progress in Chemical Sciences. I welcome you all on behalf of MN Science College, MN College Visngr. The first section will be taken by Dr. Wasi Sheikh. He is a committed, enthusiastic educator. To his contribute, he has a 26 years of experience in education, research, and industries, a very rare combination. He is a decorated teacher at MIT World Peace University, Pune. He has been awarded for teaching and one of research to his credit. He was awarded by Ideal Teacher Award by MIT WPU in 2011. He has been awarded a Best Teacher Award from Savitribai Phule Pune University in 2019, and also under the Young Scientist Scheme, he has received a funding from DST New Delhi. Looking toward his career, he started his career with as a production chemist with Asian Paint India Limited in 1992. Later on, he worked as JRF and SRF on a DST-sponsored research project. During his PhD, the topic was liquid crystalline polymer in 1999. To his teaching experience, he has taught polymer science to graduate and postgraduate in the Shivaji University, Kolhapur, and Sardar Patel University, Vallabh Gujarat. About his multidimensional personality, he joined MIT World Peace University, Pune in 2001, and at present he is a full-time professor at the School of Chemistry. Dr. Vasi is also a recognized PhD guide in chemistry as well as chemical engineering. He is also a member of Board of Studies and faculty in Chemical and Petroleum Engineering at Savitribai Phule Pune University. About his capability, he has taught the establishment of polymer chemistry research laboratory and industrial oriented PG programs. MS3 Industrial Polymer Chemistry at MIT World Peace University. He has written more than 30 research papers, few research projects, worked as a consultant, published a patent, and given an invited talk, and has also helped PhD research students. Under his direction, all PhD students of his first batch were absorbed by well-known companies. He is also a reputed writer at daily newspaper, The Times of India and Marathi diaries, dailies on the topic of environmental importance. We'll be grateful to welcome you, sir, over here. Uh, I'd like to enlighten his topic, that is microplastic source sampling identification method, prevalence and its ecological impact. So it is a very current topic. I welcome you, sir, and welcome you on the dais to take over the session.
Very good morning to one and all. At the outset, I would like to thank my dear friend Dr. Rajesh Mode. We are together, we are associated since long, maybe around 20 years. And I thank MN College for inviting me here to present my talk. Basically, I thought of when I was invited, I was just confused which topic to be covered in the conference. But since the title says recent progress, so I thought of talking on microplastics. So microplastics is a very recent area, and before I proceed with my talk, I just want to know, as I'm a teacher apart from uh, being a researcher, I just want to know from all of you, how many of you really know about microplastics? I'm asking this just because uh, I can give the talk in a proper way at looking at the level at which you know it already. So can you please raise your hands and so that I will understand how many of you really know about microplastics. So just like you, I was also not aware of microplastics when I started doing some research. I wrote a very good review few years back, and then I think this idea of microplastics will be very much clear after my talk to all of you. I can assure you that. One more reason why I thought of covering this topic in this conference, international conference, is okay. I have one more question to you. How many of you are PhD research scholars? Okay, almost 50%. And how many of the remaining students would like to go for PhD? Okay, few of you. So the reason why I have choose this topic is because I want some of you to take this topic as a topic of research for uh, your PhD. Because one thing you will realize in the end of my talk is that there are very few researchers in India, those who are actually working on microplastics. And this is the word is micro, but the problem is bigger. And you will realize it when I start giving my presentation. So this is one of the upcoming area where you can choose this as your topic of research and do your PhD. So without wasting much of our time, I would like to start with my presentation. So this is my university, MIT World Peace University, from where I belong. I'm working here since last 22 years. This is a picturesque building campus of our university. This is part of it, but this is in the heart of city of Pune. So see, as most of you said that you don't know what are microplastics, the concept of microplastics is very simple. The plastics which are micro in size, they are microplastic. Okay, it's not very a very complicated thing. So you can look at this, and these are the microplastics. So which points I am going to cover under this area is what are the different sources, from where do we get microplastics, how to do the sampling. That is another big challenge for microplastic sampling while doing research. Then identification methods, how to identify that these are the microplastics. Then prevalence, where do you find microplastics? And ecological impact, means how it is impacting us as a human beings, how it is impacting the nature, and why we should study microplastics. And then also I will talk about its toxicity. Is it really toxic? Is it going to harm us? So basically, let us start with what are microplastics. So if you look at this, so these are the small fragments of plastic. Okay. And then these fragments, see, we have to classify. Otherwise, we have so many things lying around us, and then which should be called as microplastic, what should be called as nanoplastic, what should be called as mesoplastic. There are different categories. So for the sake of understanding and convenience of study, we classify them. So microplastics are those which have dimensions in the area of 0.001 to zero point 0.5, 5 millimeter. It's quite big, but quite small also. But then we have macroplastics, we have mesoplastics, we have microplastics, we have nanoplastics also. So the problem with microplastics is you can get microplastics from anywhere. Okay, for example, large plastic products. Whatever plastic products are there in existence, some way, sometime, we are going to discard it. And it happens with almost all things. We discard everything after its use. Maybe metals are discarded after several years. Wood is also discarded maybe a few years later. Plastic is also discarded. So larger plastics, because of UV radiations, it can be because of some mechanical action like waves. Waves means I'm talking about in marine environment. So they get converted into smaller fragments. One thing all of us know about plastics is that they do not degrade. It takes hundreds to thousands of years to degrade the plastic. And when they are degrading, this is one of the stage when they get converted into microplastics. Clothing, for example, you might have seen if you are using uh, washing machine in your home, there is a filter there. Have you checked it anytime? So you just check the filter. There are small fibers coming out of this cloth every time you wash it. So these are nothing but microplastics. And they are, if you just imagine where they are going, ultimately they are going into sea in the marine environment. Then we have nurdles like small micro beads. They are purposely prepared for some application. I will tell you what kind of applications. Then uh, we have some microplastics in beauty products also. You might have seen some scrubs. We try to exfoliate our skin to look beautiful, but then we are using microplastics there. And these microplastics, they are not degradable. They remain for thousands of years in the environment. So there are different sources through which you get microplastics. So if you look at the overall classification from where do we get microplastics, you will understand that even tires, आपने देखा होगा, if you might have seen that these tires over a period of time they lead to wear and tear. So they are leading to small fragmentation. So that is also microplastic. Then synthetic textile, 35% of it comes from synthetic textile. City dust has around 24% microplastic in our cities. Then road markings, you might have seen marking on the roads, yellow, white color, and so many other colors used. Then marine coatings, they are leading to microplastics. Personal care products, they are also leading. And plastic pellets, they are actually prepared at the time of or before you process it. Suppose you want to convert plastic into some article like chair or bottle or anything, you first have small beads. So, but that contribution is very small. It is just 0.3% because these beads nobody throws away. So basically, they are classified into primary and secondary. To make it very simple, primary are those which are directly prepared in the industry for some application, and secondary are those which are produced after degradation. There, say for example, I have a pen, I'm using it, and after certain years, this pen, you're maybe after 1 year, 6 months, 3 months, you are just throwing it away, and that pen lies in the environment, gets degraded, converts into microplastic. So primary is one which is prepared purposely in industry, and secondary is one which is happening due to degradation, breaking of plastic. So I think pictorial presentation will make you understand it more better. So primary, for example, facial scrub. Then toothpaste also has some microplastic. We have some cleaning soaps also. They also have microplastics. Textile also leads to microplastic formation. Secondary carry bags, for example, some containers, some glasses, disposable cups or something, styrofoam, they get degraded over a period of time and they get converted into microplastic. Now, if you look at the background, the thing is that plastic has become very, very essential part of our life. Uh, we call this age as a plastic age also, because earlier we used to make use of stones. We call it as a stone age. Then came bronze age. Then came so many ages, and then now it's a plastic age. Because right now, even if you look around yourself, most of the things here are made up of plastic. The chair on which you are sitting, the carpet here, it is made up of plastic. This podium itself is made up of plastic. So many things. Everything is being replaced with plastic. So there's no replacement for plastic as of now, and it will not be there for so many years. Then, if you look at the world's plastic production, you will understand it has reached 360 million tons from just 1.5 million tons in 1950. So last 50, 60 years, you look at the growth of plastic. Then about 70% of the plastic gets disposed of. Okay, discarded. And plastic waste is 8%, means whatever kachara you collect from the municipal waste, out of that, around 8% is plastic waste. Then it takes thousands of years to degrade the plastic, and then it ends up in the environment. We are seeing this garbage everywhere around us. The problem is not with plastic. I always tell this thing in every conference, every talk. The problem is with us. We are not handling it properly. I can give you example. We have knife, and I would say half katta hai. So what do? We discard the knife? No, we use responsibly. So similarly, plastic has to be used responsibly. What we do is we get a carry bag from market. It is free of cost. We feel like that it is free of cost, and then we throw it away. But it should not be done so. So we need to educate the people. So see, one of the best thing about plastic is that plastic can be recycled, and it can be recycled easily. So that is what we should do. But we're not. We are very careless about it, and then we are blaming plastic. Plastic is bad. Gun is bad. Then why do you produce guns? It can protect your country. But at the same time, if you ban guns, what will happen? So if you are using guns very responsibly, if you are using knives very responsibly by the doctors, maybe to make do the operations, why not plastic is being used responsibly? So the problem is not with plastic, problem is with us, and we are not using it, and that's the reason why it is making nuisance around us. So finally, if you look at the marine litter comprises 60 to 80% of the plastic, because whatever garbage is collected in and around us, that finally finds its way in the marine environment. आखिर में वहीं पे जाता है. Everything goes there. And look at it, 60 to 80% of plastic it has. Whatever garbage goes to marine sea, out of that, out of 100, 80% is plastic. So microplastics are everywhere. Probably we don't know it. They are in deep oceans. Studies have been done. मतलब जहां पे हम पहुंच नहीं सकते वहां पे भी प्लास्टिक है, माइक्रोप्लास्टिक. They are in rivers, they are in lakes, they are in ponds, they are found in Arctic snow, Antarctic ice, where nobody goes actually. And how come that microplastic is there? It is found in fish and so many aquatic animals, which is supposed to be food for so many people around the world. Then it is in drinking water. You'll be surprised to know it is in beer also. Then it is in the air, falling with rain. Then over the mountains, it is in your salt. Okay, and everywhere in cities. So there is no place where microplastic is not there. Microplastic is everywhere nowadays, and that's the reason why it becomes very important for us to look at this problem and try to find out the solutions to this. So why the study of microplastic is important? So because microplastics are consumed by marine animals, and they have been detected in planktons, very small animal in the marine environment or in water, and whales also. Then it is there in commercial seafood, fish. Then microplastics can bind with other harmful chemicals. This is one of the very important points. So it is not only microplastic. Along with microplastic, it carries so many poisonous things. It has that attraction between some organic, because plastic is organic in nature and there are organic impurities in nature. So there are so many uh, chemicals which can bind with microplastics, and that microplastic becomes a vector. It carries the poison along with it. It goes into the animals, and it can target so many organs in the animal body that I will tell you later. If microplastics are smaller than 20 micrometers, they can enter the circulatory system. In our body, circulatory system means it can go in your blood. Then in 2017, United Nations resolution discussed microplastics and need for its regulation. This is very recent that way. So you can understand that from the picture, that how it can go, it can enter in our body. Why we should be worried? It is found in commercial seafood, packaged drinking water. Even though we call packaged drinking water as a safe water, it still has, it can have. I'm not saying that every packaged drinking water will have, but study has found that in even in packaged drinking water there is a microplastic. Then it is found even in breast milk in humans, human blood, found in liver, in lung tissues. Nanoscale MPs can cross the blood and brain barrier, so it can enter your brain also. Then plastic food containers shed huge number of tiny pieces. For example, if you are using plastic coated pans in your home, you are heating it, you are microwaving it, maybe sometimes plastic. It is releasing thousands of small pieces in your food. So we have to decide whether we should make use of such things in our day-to-day life, or particularly in these applications. Then fine particles can translocate to other organs, causing damage. So there are so many organs, vital organs in our body where microplastic can reach. And that is the reason why we should study microplastics. They are there in marine environment. I think second point is really very important. By 2050, it's not very too far, the weight of plastic in ocean will overtake the weight of total fish in the ocean. So how many fishes are there? If you collect and weigh it, the weight of plastic, not only microplastic, because plastic is finally going to get converted into microplastics. So weight of plastic will overtake the weight of fish in the ocean. So you can just imagine what is the scale of the problem. So there is one area in Great Pacific Ocean. There is a garbage patch, and it covers almost 1.6 million kilometers. Can you imagine this area? It is there in the sea. Already plastic is floating there. We are not even aware of this. It's 1.6 million square kilometer in the ocean. Plastic is floating right now. So that's the reason why this point becomes really very important. Toxicity. It may accumulate heavy metals from the surrounding, and we know what heavy metal does to our body and animals. Persistent bioaccumulative and toxic compounds, pesticides, organic pollutants. So all these can be accumulated on microplastic, and that microplastic can translocate to your body, or it can translocate to the body of any marine or aquatic animal, or for that matter any other animal, because we are not aquatic, but still we are getting it. So toxic chemical additives like plasticizers are there, flame retardants are there. They are already added in plastic. Antimicrobial agents are there. They can leach out. They can come out of the plastic over a period of time. You might have seen that, say for example, if you're using some plastic article bottle, for example, it smells. Okay, so some chemicals are there, and that's the reason why it is said that we should use food grade plastic. So those who don't understand, they can use any plastic. But those who are really understand, because in food grade plastic, those harmful chemicals are not there or they are very less. So they serve as a vector, as I said earlier, and they cause issues such as potential endocrine disruption, developmental issues, and thyroid problems in our body. Then MPs are found in gut of fish, in the digestive tract, sea salts, edible fish that we have already mentioned, muscle and liver, everywhere in the fish. So you can get, for us, we can get through inhalation, through injection, and dermal contact, means through skin also. So these are various effects of microplastics in human body. So I have tried to make a list. It's very elaborative. So many things. I could not put so many because of time constraint, but there are so many other issues also. You can just have a look at this slide and try to understand what effects it is causing in us. And still, I am telling you that everything is in preliminary studies. You will find that over a period of time, it is making more harm. It is more harmful than this, whatever you are saying here. Ecological impacts. There's a declining trend of coral. Corals are there in aquatic or marine environment. So they are decreasing. They are decreasing where you can find the plastic waste. Then microplastic was also reported in lake sediments, in lakes also. Then food grade salt, I have already mentioned. Fishery catch has drastically declined. Means whatever fishery was being done, fishing was done, being by the respective people. So that fishery catch has declined. Means number of fishes they used to catch, that has gone down. That means population of fish is gone down. Then water quality indicators, BOD, COD, what we call it as, that is also getting disturbed. Then microplastic ingestion by fish and other aquatic animals. So many other animals. I'm just giving example of fish for the sake of understanding. So every animal in aquatic environment is getting affected. So how to do this microplastic sampling? This is a kind of research part. So it can be collected from land, it can be collected from water, it can be collected from air. It can be collected from sediments also. It can be collected from biota, means animals and living organisms. There are three main challenges if you want to do research in this. First of all, how to catch microplastics. Because say for example, you want to study the particular area in sea. So how are you going to catch hold of microplastics? It's very difficult because they're very small in size. So capture separation, because when you catch something, I mean, when you collect the sample, it is contaminated with so many other things. There are so many other organic matter. So how to separate it? That is another issue with reference to research and identification. Once you catch it, so how to identify which kind of plastic it is? So that is another issue. So these are the three basic problems, challenges. And then you can do selective sampling as well as bulk sampling. So selective sampling is you are targeting particular area only and you are taking that much area, that much amount of water, and then you are studying it. And bulk means you are covering large area and then averaging it out. So another important thing is that when you collect the sample, right now, right now, there is no standard protocol. That means methods have not been defined even today. How to collect the microplastics, how to study it. So currently there is no standard protocol. Several methodologies are used depending upon the research scientists, their vision, their understanding. They use their own technique. So techniques are there, but standard technique is not there. So what will happen? If I do my research, somebody will do his research. My results will not be comparable with his results. I'm not saying his results are wrong. I'm not saying my results are wrong. But my measurements are different. His measurements are different. So you cannot compare. Okay. So there should be some unified method so that you understand and compare with each other. The density of water, because plastics, they are light in weight. So some plastics can sink in water, some plastics can float in water, and some plastics are there in between. They are suspended. So if density of water changes, this is with reference to saline water, marine water, jahan pe we have salt in water. So density is higher. So and there are certain areas where river is coming and that entering into the sea. So their density can be different. So when you check the, I mean, when you are sampling the microplastics, the density will make the difference in population of microplastics. So density is another thing. Then there are different collection tools. I'm not going to read all of them, but I have shown you some of uh, the tools in picture over there, and then that can be done. This is for marine environment. You can also collect microplastics from beach. So here there is one method, wet peroxide oxidation process, to rule out organic matter. So if you look at the picture, so what we are doing is initially we are collecting the sample, then wet sieving, that means you are filtering it according to their size, they will get separated. Then they are heated in oven so that you are removing all the moisture and only solid waste remains. Then wet peroxide oxidation reaction is done. Then density separation is done. Then filtration is done, and then finally you observe it under microscope. So when you do that wet peroxide oxidation, most of the organic waste is removed. Okay, density separation will allow the non-plastic material to settle down. So that is how you can check it under microscope finally. But that is just visual observation. There are so many other sophisticated techniques that you can use and check the microplastic. So as I said, density separation, filtration using Wattman, GF or A filter paper, then microscopic observation. Use of CaCl to solution or NaCl to stir sand samples, because if you use, you are creating, changing the density of water by using those salts, and you are extracting the sample with nitric acid so that you are digesting the organic matter. Then sampling protocols. Say for example, if you want to find out microplastics from fish, see you can do this in collaboration with zoologists also. Okay, if you have zoology or biology department, and if you are from chemistry, so you can come together and do this research. That is possible. So digest the fish intestinal content. Digest means not by eating, by chemical digestion, with 3 times excess of 10% KOH for 5 days at 60 degrees centigrade. So if you keep it there in 10% KOH, that will consume that organic matter and then filter through millipore filtration. So nothing happens to plastic. So plastic will remain, and then remaining things will filter out. Other methods include dissection and depuration. Then to isolate dissected tissues, saline wash, density flotation, separation that we have seen in earlier slide, and then visual inspection initially. Then depuration is nothing but, so what is done is that animals in empty absent media. That means you are supposed to take some media, say for example saline, distilled water, and you are putting that animal, that part in that water. So that water doesn't have microplastic initially, but that microplastic will come out. Uh, Complete gut evacuation followed by assessment and quantification of microplastics. Quantification means you are finding out how many microplastic pieces are there in every fish. Then sample is chemically or enzymatically purified. That has to be done, because if you don't do that, chemically or enzymatic purified means you are removing organic matter. Otherwise, what will happen is organic waste or organic matter will interfere with your plastic. So plastic is not affected by most of the chemicals that, for example, 10% KOH that you are using, but organic matter will be affected. So there are various methods, identification and characterization, how to identify plastics, what kind of plastic it is. So I think I have one more very elaborative table of the same thing here. I will show you that table after some time. And then morphological characteristics. So what morphological means, how it looks, what are the different colors, size, shape, then what is the degradation process, how long that plastic is lying in the environment. So all those things can be done here. So it helps to classify and determine source of microplastic. So you'll understand what kind of microplastic it is, from where it has come. So that will tell you, you'll get that information from morphological studies. Then degree of yellowing. You might have seen that when you bring something transparent plastic from outside, over a period of time, it becomes yellow. So that it is happening because of degradation. So that yellowness is directly related with the time. So how much time it is exposed to how much radiations and how much yellow it becomes. So that will tell you for how long that plastic is lying in the environment. Then roughness of the surface. So you might have seen again when you bring something, some new plastic from market, it is very shiny, very bright in color and everything. But over a period of time, that shininess goes down. It develops some cracks on it. So that study can be done so that how long it is exposed to various environments. Specific cracks, aging, mechanical and oxidative weathering that is studied here. The molecular structure of MPs may change due to various environmental factors. So what happens is when this plastic remains in the environment, it is getting in contact with so many chemicals from the environment. So what is happening is some chemical reactions are also happening with the plastics, and they are leading to some changes in the structure. Molecular structure of the plastic also changes. Some COH groups, some hydroxyl groups are formed during the reaction, because degradation is a very random reaction. It is breakage of bond, formation of new functional groups, removal of earlier functional groups. It's very random. Anything can happen during degradation, because degradation is not a controlled reaction. It is happening because of so many factors available there. It can be water, it can be acid, it can be UV light, it can be some mechanical force. And that's why there are so many things happening with the plastic, and that's why we'll see that there is a change in molecular structure. Then carbonyl index is one indicator that tells you relative age and weathering pattern of plastic. Carbonyl index. You might have studied infrared spectroscopy. So you get that carbonyl peak there. So that peak of carbonyl group changes with respect to time in plastics. So that will tell you how long it is lying there in the environment. Spot and color tests are there, just like what you do in identification or uh, other regular practicals that you do in organic chemistry. So I think this is what I was talking about, various techniques. So visual inspection or identification is very rough technique, just to make primary confirmation that it is a plastic, but it is not very conclusive test. So it is less accurate. Stereo microscopy is used. You actually observe the microplastic under microscope. Then SEM, EDS. There are so many techniques. I'm not going to read all of them. So all of these are being used for the identification of microplastics. So what can be done in future? So one thing is implementation of recycling that can be done from the other point of view, not from our side, but of course that can be another point of can be a point for research. Then policy making, then use of natural resources instead of plastics, ecotoxicological studies, they are not being done. How microplastics are affecting, particularly I'm talking with reference to Indian scenario. In India, you will be surprised to know the research on microplastic is very less. I have done some statistics in next slide. Then terrestrial system studies means in which area, how many microplastics are there, which area is not affected, which area is affected, that must be studied. Rubbers should be treated as microplastics. They are treated, but they are not found in the studies. Then sorption, desorption, and leaching dynamics. That means suppose some microplastic has some organic pollutants on it. So how much organic pollutant is being released and how much it takes up from the environment. That study has to be done. That can be done by anyone. You need not go to sea or marine environment. What you can do is you can have microplastics, coat it with, put it in some uh, polluting environment, artificially created polluting environment, and then do its kinetic study. how much uh, uh, impurities are or toxic chemicals are released by the microplastics. That can be done in laboratory only. Then one review I wrote, I think 2 years back. So I have done all the study. Means this is the first review that happened in India for the first time on microplastics. There was no review till I published this review. So here what you can see is that I have tried to find out the different areas where microplastic study was done, and you will still see that particularly if you look at the area of Gujarat, some area is still not studied. So you can think of those areas. There are so many other areas in eastern side, so where this microplastic study can be done. And if you look at the number of publications till date, aaj tak, so you'll see that there are just around 6,000 to 7,000 publications all over world. Globally, there are just around 7,000 publications on microplastics. Out of that, when I did review on microplastic, it was 73. 73 publications in India. And now that number should be around 100, not more than that, just 100 publications. So that way, this is very recent area where you can do research, you can take up this as a problem. And because I have written it very clearly in my review that this is the first of its kind of review in India, and it is published in a very reputed journal, the Journal of, I mean, Science of the Total Environment, which has impact factor of 10 plus. So this is what I wanted to emphasize finally, that this is very upcoming area where you can definitely give some attention if you are thinking of doing some projects or research. So that's it from my side. If you have some questions, you can ask those questions. Thank you. Any questions? Yes, please. I think if you have listened my talk carefully, uh, the thing is the work that is done as far as data, how harmful it is in still preliminary stage. So nothing, particularly in India, it is not done, not done. And world over, it is being done, and but it is in an initial stage. Yes, sir. Yes, please. Basically, what is done is these microplastics are dyed with fluorescent dyes. So they get adhere to the plastic, and they get that give the fluorescence under microscope, polarized microscope. So otherwise, other organic part is digested and it doesn't remain there. If some, for example, sand is there or something, that will be discarded by that density set. Yeah, that is one of the method. That is one of the method. There are so many. No, no, no. These dyes are reactive. They will react. They will react. They will adhere to the surface. They adsorption. Yeah, so it will be simply adsorption on the surface. Yes. Yeah. So what? Sorry. Not really. Actually, you are using dyes. You are using dyes which are fluorescent under polarized microscope. So when they adhere, they get adsorbed on the surface. That can be detected under microscope. Yes. Yes, yes, that is done. That study is done. Yes, yes. Different classes, like for example, polyethylene is there, polypropylene is there, polystyrene is there, PET is there. So that study is being done. That is a part of the study. Hmm. See, I will tell you something, that every plastic that is being used, the study is done for those plastic from the garbage only. So the plastics that are studied and they are being found out in this study, they are from average class. I mean, they are from they are polyethylenes, polypropylenes, PET is there, polycarbonate is there. Every plastic that we use. So that study is done. That study is done. Type of plastic. Means you are referring to the names only or something different? Yeah, these names are there. Polystyrene is there, polypropylene is there, polyethylene is there, PET is there, polycarbonate is there, nylon is there. So all these plastics will find. Of course, they are in the ratio of how we use it. For example, polyethylene will be more as compared to polycarbonate, because polycarbonate usage as such is less. Nylon will be again less as compared to polyethylene or propylene, because polyethylene, polypropylene, these are commodity plastics. We use it in almost all applications, packaging, silicate, and most of the things. I mean, applications are based on. I mean, sorry. The thing is, the most of the discarded plastic is from packaging industry, because use it and throw it. It is immediate. That's why. Specific plastics are less. Specific category like polycarbonates, nylons, high performance polymers, they're less. Yeah, it was not mentioned here because everything cannot be covered in such a small talk. But I can definitely send a link about my review in which I have mentioned everything, even for his question, sir, your question, sir. I have made a table, and I have not left a single point. Whatever study is done, I have done with reference to India, and I have not left a single paper which is not there in this review. So as I said, 73 publications still date, right from maybe 20 years back, right from the first published paper. So everything is there. So you are talking about microplastics in groundwater. You can just imagine if it is in our brain now. So getting into groundwater is not difficult. So it is found in groundwater also. It is there in groundwater. Yes. I really No, as far as startups are concerned, I know few startups, those who are working on bioplastics. Because no, no, bioplastic. I'm talking about bioplastic. So people are now shifting towards bioplastics. Like Surat, recently Surat has been making road, plastic road. So this is a Denmark company. So which could you tell me which company is the major impact in the all over the world, like recycling point of view? No, I'm not getting your question, but the point, as far as recycling is concerned, there are so many companies in India, those who are converting plastic waste into fuels. Some plastic waste is like they're trying to depolymerize. For example, some polymers like PMMA can be depolymerized. Because DuPont is making construction chemical company, construction chemical, which is insulation chemical. So this is the main construction chemical from the plastics, microplastics. So this is the major impact in the recycling and reuse plastic. The construction chemicals from microplastics. From microplastics. Yeah. How is that? Uh, because construction chemical have so many insulations. And insulations is the polythene. Or polythene and PVC and polythene. I'm not getting you. I'm not getting you. Last year, DuPont is making announcement. Like, DuPont is a very famous company in the area of US. So last year, in making announcement about construction chemicals making from plastics. But where is the question of microplastic? Plastic is microplastic also used in the microplastic. Which company is कई company use very successful. Next, recycling ना point of view कई ना use करते. अच्छा, you want to say that which company can use microplastic? As a theory, as a part of the all of the theory. Company as a standard कोई लोग बोलता है. कोई ये इतना कई ना use करी सकते हैं. See, first of all, I understand Gujarati very well. Uh, because I was in Vallabh Vidyanagar, I was teaching students like you. I taught there along with Mod Sahib for 3 years. So, uh, नहीं लेकिन इसका मतलब गुजराती में मत बोलो. So, see, the thing is, you should not be using microplastics, even though if you think of starting some startup and you want to use microplastic, I suggest don't use it. Because that's what one of the point I mentioned is that there are some microplastics that are already used and they are purposely made. For example, in beauty products, in scrubs, toothpaste, soaps, they are finally ending in some, yeah, finally they are going into environment and they are coming back to us. Nature has that very beautiful way of giving back everything to us. जो हम डालते हैं वो वापस हमारे मुंह पे ही मारता है ना? We have seen it during pandemic also. Yeah, how to prevent? Right now, to be very frank, there is no solution. The only solution can be bioplastics right now. So, lot of people are doing research on bioplastics, which can degrade completely. Bioplastics will be the plastics that will degrade completely. They will leave harmless chemicals in the environment. So that can be one solution. And second is being responsible. Don't throw it anywhere. Don't throw plastic in open environment. Just like we used to spit everywhere earlier, but pandemic ने हमको सिखाया मुंह पे बंद ही कर दिया मास्क लगा के. Don't spit. So just like that, don't throw the plastic. Recycle it, reuse it, and that is how you can reduce it. You cannot eliminate. Bioplastic can be the solution. Bioplastic is the only solution in sight right now. Yes, yes. And that study has been not done still. What kind of things are happening to our body, to the animals, that is not, perfectly studied so far. So that can be done. So that's why I'm trying to tell you that just around 6,000, 7,000 papers globally on microplastics and just 100 papers, that too just study of microplastics, not its ecotoxicological effect. Getting it? We studied microplastics, not its effect. Out of these 100 papers, you will find hardly any paper which talks about how it affects our health. That is not done. Any other question? Okay, so lastly, I again thank my dear friend Mod Sahib for calling me here. It was really pleasure coming here, talking to all of you, and I feel very nice you asked me questions because that shows that I have created some interest in you, and that will be definitely just a minute. So that will definitely be good inspiration to me as well to take up this issue in various conferences and various talks and make the people aware of it so that we should start working on this. Yes.
To identify how old is microplastic?
Carbon dating method I have not come across so far. So I'm really doubtful about it. Okay. Most probably no. I'm not very sure to be very frank. Because uh, I never came across it. Thank you.
Thank you, sir.
Come here.
Hope he has satisfied your all
Thank you, madam.
questions.
Thank you. Thank
Uh,
you. Thank you.
I thank him on behalf of Team College and this conference. He has touched the most sensible, recent topic according to the conference, and everybody has shown their interest. But in the very first of his lecture, he has stated that plastic is not a problem. The way we are using it is a problem. So that was the remarkable statement made by him. So if we stop using or discard the way we are discarding, the research field may get end up. But then also he has put forward. Uh, so I thank you on behalf of this team, and I'd like to felicitate him. I welcome Dr. Moore sir to felicitate him for his lecture.
Thank you, sir.
We will be continuing to second session, which is in online mode.
Good afternoon, all of you. I am Vipul B. Auditya. Today, thank you very much, all of you, to give organizing committee to give this opportunity of chair session of international conference of recent progress in chemical science. Thank you very much, all organizing committee members. Now I would like. I'm Vipul B. Auditya, working as a assistant professor at Municipal Arts and Urban Bank Science College, Mehsana Department of Chemistry. Now, I would like to introduce today's speaker, Dr. Pankaj Sharma sir. Pankaj Sharma sir is received his PhD degree in the chemistry from Jivaji University, India. He worked as a senior lecturer at Lovely Professional University, Punjab, and University, Haryana, India from 2008 to 2009. In December 2009, he joined Myongji University, Republic of Korea, as a research professor. After that, he worked as a research scientist at the Korea Institute of Energy Research, research professor at Changam, Changnam National University, and senior scientist at the Ulsan National Institute of Science and Technology, Republic of Korea. Presently, he is working as a Marie Curie Fellow at Cardiff University at UK Catalyst Hub, United Kingdom. His research interests include the photoelectrochemical production of the future energy carriers H2O2, NH3, ammonia, hydrogen, photo reduction of CO2 and C2 plus products, photochemical, bio-waste, valorization, integration of catalytic processes, photoheterobiocatalysis for the valuable chemical synthesis, and photocatalysis for medical applications. Now we enjoy the dynamic personalities lecture on solar and seawater for clean energy production and storage. Now, dynamic personality Dr. Pankaj Sharma sir. Uh, hello, hello, hello. Welcome, sir. Was in- Not listening. Okay.
Hello.
Yes, sir.
Hello.
Yes, sir.
Hello. Hello.
Sir. Clear, clear.
I cannot hear from your side. Okay.
Sir, clear. Voice is clear. Start, sir. Please.
Okay. And good morning. Although I could not hear any voice from your side, so I will start my lecture. So before that, I would like to thank Dr. Suresh and the team at ML College for inviting me to this conference and giving me an initiative to organize this kind of programs and many more in the future. So before we starting my presentation, about the facility available at the UK Capital Hub, and this is a dynamite source. It's a national facility in UK. If anybody is interested to do any experiment at this facility, they can write a proposal, and someday they will fund their journey and their experiment if there is enough science in their project. So I would like to invite all the people who are attending this conference, if they wish to write a proposal and want to use this dynamic light source facility, they will facilitate you, they will help you to carry out some really exciting work at dynamic light source. So there are 22 beam lines. Anybody can use that. I am working at UK Catalyst Hub with Professor Richard, and my research is mainly funded by European Commission and NRF South Korea. So I will start my research work, and as this presentation is on catalysis and recent progresses in chemical sciences, so I decided to go with solar and seawater for clean energy production and storage topic. This is my research team, and I'm working in this field from last 6-7 years. So why I choose this? If I have to look into Indian map, then Gujarat. If has high solar power density. So working in solar field, Gujarat is a best place where we can do research on solar energy, and moreover we can implement this research within the state and provide a energy and another resources to Gujarat. The another is sea. If you see, Gujarat has longest sea border line compared to other states. So working on sea or seawater batteries or any other field with the seawater, then Gujarat is an ideal place to work on seawater batteries or another possible fields in seawater. So I will start my research presentation. I am working on green fuel and green industry for green environment and carbon neutral society. So my research team is mainly use of all the natural resources, either it is sun, air, water or biomass for clean energy and green environment. So as you all know that greenhouse gases emission to environment is quite large, especially in developing countries like India and China. They are emitting a large amount of CO2 to environment. So it's our duty how we can minimize that emission to the environment, although emission from all the sector, whether it is agriculture, industrial or transportation. So how we can minimize CO2 emission to the environment with producing other valuable chemical. It's not like that we just have to capture CO2. We have to transform that CO2 another valuable chemical. So these are the few ways on which I am working, how we can generate carbon-free green fuel. So there are many possibilities where we can use green carbon-free energy resources like hydrogen, hydrogen peroxide and ammonia, ethanol and many other products. So second thing is developing a greener process for chemical production. It's not only to produce green fuel, but it's also how we can transform those CO2 emitting process to greener process in the industry. That's another target of my research. And replacing fossil fuel with carbon-free energy fuel, it's not that easy task because to convert, to replace fossil fuel with green energy fuel. So we not only need fuel, we also need a sustainable development and production with a larger amount and also technical changes in the use of these fuels. Renewable energy storage in milk. Although we are storing solar energy in electrical energy, but that's not enough. We need batteries to store and keeping that energy. Other way is to how we can store this solar energy or wind energy or water or biomass to another renewable chemical or other products. So those are easy to store. Storing solar energy, wind energy in electric form is not the only alternative. So transforming agriculture, it's the biggest problem in India. Not only its management, but also it generates lots of CO2. CO2 and its emission to environment. And another is how we can go for these. We can go with novel material synthesis and generate all these products. Novel material synthesis, we always need a novel catalyst or novel material which can fulfill all these requirements and help us in producing all these renewable resources. Like all these, this energy cycle shows emission of gases, CO2, NOx or any other, and we have also bio-based like from agriculture or tree, but we are also at the same time water, air, sun. So if we can generate or produce some useful material which can transform or capture all these gases from environment and can easily transform them to valuable chemical or green fuel, it can be photocatalyst, electrocatalyst, heterogeneous catalyst or biocatalyst. And we can put all use different combination to achieve this goal of green fuel and green beneficial to young researchers who don't even start their work in the research and willing to do something in this research field. And another thing, generation of green energy is also a big challenge, not only for developing country, even for developed country. If in the present scenario we see that energy crisis it at peak, so we need an energy demand, and especially India needs energy quite a lot for its growth to a developed country. So these are the research topics on which I am working right now. I will discuss one by one these research areas. First is solar fuel and valuable chemical production. Solar fuel is not only hydrogen, it can be hydrogen peroxide and ammonia. Maybe many of you know about how we are transforming these fuel cell, not only hydrogen-based fuel cell, but hydrogen peroxide or ammonia-based fuel cell, which use in automobile companies. And second is bio-waste valorization. There is large amount of bio-waste generating every day, so we need to transform this generated bio-waste into a valuable chemical. Like harmful gases, NOx, we can reduce them to ammonia. Ammonia is also a carbon-free green fuel which can be used in fuel cell, modified fuel cell. Another research topic on which I am working is photocatalyst for cosmetic. So if you see sunscreen, there are many photocatalysts which blocks UV radiation, but those are organic. We need a healthy material or photocatalyst which can be used in cosmetics. Another is CO2 reduction to C3 products. CO2 reduction to single carbon hydrocarbon or double carbon hydrocarbon is quite easy, but moving to C3 products is quite difficult. So that's another area of research on which I am working. And another is photocatalyst for cancer cell neutralization. This is for medical application. So it's not easy to achieve all these targets. It looks like that, okay, it can be done, but it's not easy. So we need a different strategy to achieve this target. One is I am doing indoor, that isolating the photogenerated products from its system or synthesizing. This is a different kind of strategy I am doing or taking into account to produce those valuable chemicals. Another is when you have a challenge of producing C3 products, you need not only a novel catalyst, but also need a novel sport to achieve, because control of intermediate or final product depends on the generation of intermediate. So with the catalyst, we have to think about the sport. And those who are working on CO2 reduction, they know both catalyst and sport play a vital role. So my work is how we can use a novel sport to convert CO2 to useful products. So when you are thinking about transforming one waste to another, then there is different strategy. You cannot easily trap or capture CO2, NOx, or any other products which is or a reactant which is of your target. So there is some strategy into the reaction system where we can choose an ideal electrolyte which can help us to transform that feedstock to a valuable product that is trap and treat. And sometimes a single catalyst doesn't work that well. Then you have to think about hybridizing two different catalytic systems. So this is another strategy I am adopting to carry forward my research. Solar, it's well known that solar can fulfill the demand of human need or energy. Just a single day energy reaching at Earth's surface can fulfill the need of 1 year energy demand. So it's not other wind or any other, they don't have that capability, but solar can do all those things quite easily. They see other potential energy energy resource is natural resources. Seawater is not only a water, it is a natural electrolyte. It can do many things if we look into seawater. So as you all using lithium-ion batteries in your mobile phone, in all other electric vehicles, so if you see in the world, main resource of lithium is sea. So if you have technology to recover lithium from seawater, then it is nice and it can be. So there are many different technologies people are developing how we can extract lithium from seawater. It's not that easy because amount of lithium in ocean in comparison to other metal ion is quite low. So it's quite challenging, but if we can recover lithium, or people are already, researchers are doing different research in lithium recovery, especially China and Japan, there is main target is recovery of lithium from seawater. So again, in that solar energy can also play a vital role to recover lithium or other metal. Not only recovery of lithium, distillation of seawater to fulfill the clean water need. Solar energy is playing a vital role. So third, renewable energy resource, or we can say that waste which we are generating every day is bio-waste. This can be a very good feedstock to generate many valuable chemicals. So fourth, which is the target is air. It's not only wind energy. In air we have CO2, O2 and N2. These can be easily converted to, not that easily, but there are still some challenges with the CO2 conversion to valuable chemical, but people are already working, researchers are already working how we can convert O2 or reduce O2 to hydrogen peroxide or N2 to ammonia or CO2 to alcohol or hydrocarbon, or you can say that synthetic petrol. So that's the research field. So before starting my research outcomes or showing what I did in recent time, last 5 years, so this is the review article written by me and my team at UNIST. So this review article highlights solar energy, the possibility in solar energy, and there are three kinds of system: PV based system, photovoltaic based system, and direct use of solar energy. If you see in the graph, if we see PVEC, if you people don't know about this PVEC is a simple system where we use solar cell to generate energy, electric energy, and that electric energy is used to split water to hydrogen and O2. So this is PVEC system. It is quite efficient, but that use of solar energy without generating electric energy is PEC, photoelectrochemical and photochemical. Photochemical is just a powder-based system where we put some semiconductor or powder in the water, like these carbon nitride or bismuth based semiconductor or photocatalyst in water, and just irradiate with solar light. It generates O2 and other products. So I feel there is a large possibility in this field if the young researcher want to carry forward their research in this field. I think this is a good chance, and especially in Gujarat, where is power density, solar power density is quite high. There is seawater, and India needs energy not only to fulfill present demand but also for future. And people's even Arabic countries, Saudi Arabia is now they are moving from these petroleum fossil fuel to solar energy. So solar energy can easily compensate 50% of the energy demand. So if you see by this graph, India is nowhere, but small country like UNIST, my previous institute, they are doing very good in polymer-based solar cells. So now I come to my research work. So green hydrogen production is my challenge, although still in
industry, much focus is on gray hydrogen or black hydrogen. Black hydrogen means reforming of coal or other products or natural resources to hydrogen where we generate O2. But in case of green hydrogen, we don't generate any CO2, no emission of CO2 to environment, even on combustion of this hydrogen resource, we don't have any CO2 emission. But the challenge with hydrogen is storage. It's not easy to store. So its gaseous form and compressed form we have to use, and compressed it's occupy a large area in comparison to organic or another liquid or aqueous energy resources, no fuels. So my target is photocatalyst, and photocatalyst is the only way to generate, apart from electrocatalyst, green hydrogen. So apart from hydrogen peroxide is another green fuel which can be used in fuel cell. So my challenge is, although anthraquinone is an industrial process, it generates lots of waste, organic waste as well as other waste. At the same time, it is using hydrogen. Now, if we see electrochemical synthesis, it also uses hydrogen. When green hydrogen generation itself is challenging, then use of hydrogen to generate hydrogen peroxide is also challenging, or especially green hydrogen peroxide. So my target is to generate hydrogen peroxide using solar light and water. Similarly with ammonia, hydrolysis process, if we are using methane reforming and generating hydrogen to generate ammonia, again it is releasing CO2 to the environment. In electrochemical, again hydrogen required to synthesize ammonia. So green hydrogen cannot be used everywhere because its production is not sustainable till now. So we need to find an alternative way where we don't need hydrogen. It is like that, converting one energy resources to another energy resources. So these are the different. So first I am going to discuss about hydrogen storage. So these are the different materials used for hydrogen storage: adsorbent, MOF, or POF. It's simple adsorption, and hydrocarbon, organic or liquid metal hydrides, they are also used for hydrogen storage. And this is familiar when we use any alkali metal in water. This is chemical reaction, and physical storage is this, just compressing and putting into a cylinder and liquid hydrogen. So these are the known hydrogen storage material and process. So if you see all these, if we go by DOE guideline, we need to make a hydrogen storage or hydrogen production sustainable. It needs to be done at relatively low temperature, 85 degree, and pressure should not be higher than 12 bar, and the gravimetric capacity should be 5.5. All these existing doesn't fulfill any of these required demand. But if we see alkali metal based or chemical reaction based hydrogen storage, it can easily fulfill the hydrogen storage demand. So if this is just a comparison, if we're using compressed cylinder, it will occupy a large volume in a beaker. Metal hydrides can be used, but they are not a reversible process. So in this paper, we try to highlight that seawater battery can be used for hydrogen storage and can transform hydrogen energy to onboard and offboard facilities. And seawater batteries are very cheaper than that of lithium-ion battery or any other. But the problem with seawater battery, we can only use with the seawater or in near to sea, and we can transform or modify them for their uses in this is the simple structure of seawater batteries, where during charging, sodium ion from sea reduced to sodium on anode, and similarly during discharging, when your discharging happens, then in the presence of O2 in the seawater, there is a dissolved O2, then generate sodium hydroxide. So during this reaction, we find that if we remove O2 from the system, then what will be the reaction? Then hydrogen can be, water can be reduced to hydrogen. So we can generate hydrogen during discharging. We don't need to develop any other technology. We just have to remove water from the system. We can generate hydrogen from that system because it's similar to the reaction, chemical reaction. So we termed it as a chemical hydrogen storage, a method of hydrogen storage using chemical. All people, you might have did this experiment putting sodium or lithium piece into water. This is the same reaction. It generates heat and hydrogen. So this is the seawater batteries which we designed, and here we have the plan to use solar panel to charge this and generate hydrogen simultaneous charging. Here it's charging and discharging happening. So this is cyclic system. We can generate electricity, we can receive electricity and hydrogen at the same time, and we can supply this hydrogen and electricity to household, to transport and other industrial process. And so when we do research, we have to start with a smaller system when we are designing a new system. So we use a small, this nearly 2 to 3 ml reactor design. This DEM system, this is seawater battery bottom, and this is seawater to check whether this reaction can happen. So another for laboratory scale, another, this is 70 ml reactor or reactor system we designed. This is final, and all these are closely packed. This is our seawater battery, fine cell battery, and this is anode and cathode, and from there we check the hydrogen production by directly connecting to GC. And to check the its large scale possibility, we use these big scale, a pack of battery like 66 centimeter long, a box which can generate hydrogen. So this is seawater battery conventionally used in. So these data shows that we can easily generate hydrogen from seawater, and using seawater batteries during discharging. At the discharging we are getting electricity, but at the same time we are also generating hydrogen. So it's necessary for all the researchers to look into research happening around and how we can extract or put forward some important observation that can really useful. So this our observation is quite useful that during discharging process we can generate hydrogen. So this is O2 free environment after removing O2. So we find that it's have 100% Faraday efficiency. It's generating hydrogen both in small system, a laboratory scale system, and commercial system. So then we decided, okay, we don't need to remove O2. Let's see what is happening in the system. Then we find that at high discharging current, these water batteries are even producing hydrogen. So if you go by this, it's a simple observation, just removing O2 from the system and checking hydrogen. There is nothing big science behind this, and we just made an important observation. But later we find that, let's see, at high discharging current, and we can also produce hydrogen from seawater battery at high discharging current with 100% Faraday efficiency. So this shows that even though seawater battery is coming into existence nearly 10 years, but this important observation help us not wasting any products during discharging. And so nowadays, or even what we do in the research, whatever we are proposing, we need an important explanation or to confirm that that's really happening. So we did a theoretical validation. Theoretically, we find that at pH 8 we can generate hydrogen during discharging. So observation is validated by theoretical studies. So now I will come to the another important resource, that is hydrogen peroxide. Hydrogen peroxide has consumption high industrial value, so it is used in paper industry, fuel cell, and many other chemical process. So I will not go into that detail, and its market is increasing day by day. So in biomedical application, it is also. This is the research article which I wanted to share with you about hydrogen peroxide. So many people or many researchers, those are young and wanted to do research. Hydrogen peroxide production is also using natural resources. Is also a nice field to do research in this field. Especially when, so we need only a catalyst. Sun and water can produce hydrogen peroxide, and we don't need enthalpy non-process, or we don't need hydrogen separately to generate first hydrogen and changing it to hydrogen peroxide. Sun and water can easily transform to hydrogen peroxide, so it will reduce, or it will give a greener process for industrialized hydrogen peroxide production. So if the main challenge is we have to compete with sustainability and production. Although these process use of solar light or photocatalytic process don't generate large amount, but we have to work on not only the catalyst to design a system where we can reduce minimum or minimize the loss of hydrogen peroxide usually during photochemical process. So I don't know how many researchers who are participating in this conference is working on material, but in material its morphology, its structure, and its all kind of parameter we need to define. If some material, sometime like this polyheptadene amide, there are many polyheptadene amide material already since cell, but all may not have a similar performance. The performance sometimes depends upon its defects, its morphology, and its capacity. Particularly this material have CO2, high O2 absorption capacity in comparison to other gases present in the air. So the XPS, exofluorescence spectroscopy, I don't know how many people are familiar with it. This is quite a handy technique to characterize the material. It's apart from XRD, it shows that there are some really functional groups. So those who wanted to do research, each and every instrument which we used in this study, they can be a source of interest, or any student, if they want to work on, particularly on these instrumental techniques are quite handy in any research. They can choose to work on these techniques, not only material. Apart from the material, without this characterization technique, we cannot come to conclusion of how the material is working, how the catalytic activities are improving. So these are quite handy. So although not many people are using Raman and XRD, these are quite handy techniques when you are working on functional materials. This provide important information. So confirmation of cyno group, particularly in this material, is validated by the FTIR and Raman spectroscopy and BET. Many people, or I think most of the students at MN College familiar with BET absorption. This is quite also important. Not only nitrogen absorption, when we do O2 absorption or CO2 absorption, for example, in CO2 reduction, we need to understand how much interaction of CO2 with that particular material is. So this adsorption technology is quite useful to show why the material is performing well. One reason may be the high absorption capacity or interaction of that material with that particular catalyst. So this UVDR spectra or UV spectra, I think every institute or every lab has this UV visual spectra. So this is particularly in photocatalyst or semiconductor, it is quite useful. It tells us about the band gap, its absorption, its working in particular wavelength. So this is quite handy. Apart from that, photoluminescence spectroscopy. So I suggest if any student or researcher interested in this field, I suggest them they should focus on one techniques, and they are quite useful in the present time to tell us about the catalytic reaction on any catalyst, especially when you are working on synchrotron facility. These techniques are quite useful and provides very useful information. So I will not go into the detail. This shows that hydrogen peroxide production. So when we do research, we have to think about the optimal condition to maximize the performance. So these are the different using different solvents, different concentration and water concentration. This particular graph, activity in UV region and visible region, and different pH. pH not only about the stability of the photocatalyst, it also affects the catalytic reaction. So these are the different optimization process. The main thing is how your material is performing in comparison to the other. So it should be better, or if it is not better, it should be new, and it should have the potential to produce high amount of any desired liquid or energy resource. So this material is quite high performance in comparison to all other reported materials. And so again, electrochemistry comes into play. We have to think about whether it is 2-electron reaction, 4-electron transfer reaction. So these electrochemical studies, using simple potential stat, we can easily identify the reaction, whether it is 2-electron transfer or 4-electron. At the same time, we have to cyclic stability of that catalyst. So now I come to another topic. So here I try to discuss another piece of work I am doing. Here what I am doing to generate both. When we split water, we generate hydrogen or oxygen. But my target is to generate hydrogen peroxide and hydrogen from after splitting water. So it will not only give us two valuable chemicals, hydrogen peroxide and hydrogen, but it will reduce the separation. If we are generating hydrogen or oxygen in a system, then we need to separate both these gases. But if we are generating hydrogen and hydrogen peroxide will be in liquid phase and hydrogen will be in gaseous phase. So we don't need any another process or separation process. Separation process in any industry is highly energy consuming. So this is another approach to generate hydrogen and hydrogen peroxide. This will double the performance of any photocatalyst. Another strategy, oxidizing water to O2 and using that O2 to hydrogen peroxide production. So researcher can also, many researchers is working on this field. This will help us without using O2, just generating hydrogen peroxide from water and using sunlight. So, but the problem with this is the few problem I will discuss about hydrogen peroxide production in liquid phase using photocatalyst. There is possibility when we generate hydrogen peroxide, it can also oxidize on the photocatalyst surface. So how we can prevent? The simple way is just making a boundary around this catalyst It looks like simple, but the main idea is if you make a boundary that restrict hydrogen peroxide approach to this photocatalyst, then we can increase its production. It will not decompose or oxidize on the photocatalyst surface. So photocatalyst, here I want to discuss with student or researcher. Photocatalyst, they can be simple photocatalyst. Carbon nitride can be a simple photocatalyst. Even hematite or any TiO2, which we call TiO2, one of the best photocatalyst till now. High stability, high photocatalytic activity. But the issue is that TiO2 is only active in UV region. But there are many ways to reduce TiO to make a treatment to make it working in visual region. So a student or researcher can easily do an experiment in their laboratory by just using light or solar light, how it is producing hydrogen peroxide. So this is the paper where we use a hydrophobic polymer, conductive polymer on TiO2, coating it on TiO2. It prevents like this. A polymer is coated on TiO2 sphere. So this, as it is hydrophobic and hydrophilic hydrogen peroxide will not decompose or it restricts the approach of hydrogen peroxide to TiO2 surface to get oxidized. So in this way we improve the performance. So in the absence of polymer, there is no hydrogen peroxide production, but coating with conductive polymer. So this is just as in research, whatever we are proposing, we have to validate. So this broadcasting method is a simple method to check the hydrophobicity or hydrophilicity of any material. So after that, these graph shows how we improve or increase the hydrophobicity of a material by substituting fluorine into that polymer. So again, theoretical validation to check the absorption, possible absorption of hydrogen peroxide on a different polymer coated TiO2, which shows that double fluorine substituted polymer has least absorption of hydrogen peroxide on its surface that results in its high hydrogen peroxide production. So again, this impedance and electrochemical study to validate its two electron transfer reaction. Another research article is like that, using MOF and transforming MOF to CDS with some reduced carbon. This is controlled carbonization of CDS. Carbon is also a hydrophobic material, so it also prevents hydrogen peroxide decomposition on CDS, and at the same time, all photocatalysts are not stable, especially CDS has some photopoisoning effect, so it gets corroded during photochemical reaction. This also prevents
to increase the performance. The sustainability of those photo anode or photo material is not possible because ultimately we have to go for commercial scale uh, production of these materials. So this is simple when we have a simple diagram for students, young student, those are MSc, I think many are in their master course. This will get simple for that. In any photochemistry, we need charge separation. For charge separation, you can be decorated them with some metal co-catalyst or adopt any other strategy. Maximum, we have to uh, maximize the charge separation. When we irradiate solar light, these charges should reach to the surface and participate in catalytic reaction. So for them to participate in catalytic reaction, sometimes we use co-catalyst. So these are some material photocatalyst on which I am working. I just discussed only carbon nitride, CDS, and TiO2, but there are many other material on which I am working. So now I come to how we can use bio-based water, air, and sun to produce green chemical using green catalyst. This is also sometimes called if uh, storage of solar energy in molecular form. Although hydrogen peroxide, hydrogen, and ammonia is storage of solar energy in molecular form, but here we can use bio-based, where bio-based can be oxidized to fine chemical, and electron can be used to generate hydrogen peroxide, or ammonia, or other valuable chemical. So I will discuss these few published paper. This is where we use solar light to oxidize or convert lignin. Lignin is an extract from bio-based using photoelectro and biochemical. So here we use three different, not only photo, we use photocatalyst, electrocatalyst, and biocatalyst to convert lignin to valuable chemicals. So sometimes we need to hybridize different systems to come up to final products. So we can also think about the possibility of how we can hybridize different systems to come up with useful products. So this shows that TiO2, this is photocatalytic system, this is a lactocatalyst, cobalt doped carbon nanotubes. This is cathode part, and this is third. This three chamber. Here, photocatalytic reaction happening. There is electrochemical reaction happening. There is biochemical. So if you put hydrogen peroxide directly into biocatalyst, sometimes this hydrogen peroxide high concentration damage these biocatalysts. So in situ synthesis of hydrogen peroxide will be a controlled transfer of hydrogen peroxide to this third compartment, which results or helps us conversion of lignin to vanillin or other products which use in cosmetic, plastic, or many other production or many other fields. So if you see in the three compartment system, we have 100% selectivity. This shows that the importance of reactor design. Reactor designing is also an important research field. So those who are really love to work in mechanical or something industrial designing or reactor design is also an important field. This helps us or construct us an efficient system. Even though you can synthesize efficient catalysts and you have good methodology to produce, but if you don't have a good reactor system, you cannot produce. In this three compartment system, we have 100% selectivity, lignin conversion to products. Here, vanillin is the final product, so 100% selectivity. But in powder system, selectivity and yield is quite low, conversion is quite low. Similarly, in two compartment, um, if we are generating hydrogen peroxide within the biocatalyst that or O2 that have a negative effect on these biocatalysts. So reactor designing is also an important topic of research, although I am not working in this particular field, but it's really fascinating field. So here we use lignin monomer polymerization that's also quite high in three compartment system. So another is this holistically is how we can convert industrial process, those waste generating industrial process to greener process where we don't need thermal energy or any other sort of energy or system, but we can use photo energy to generate value added chemical. In this paper, what we did, we use photoelectro and heterogeneous to replace catalyst depending upon the reaction we are targeting. Here we are targeting oxidation of propylene to propylene oxide. So in this, similar to previous, here we use bismuth vanadate instead of TiO2 because bismuth vanadate is quite active both in UV and visible reason. So here we use hydrogen peroxide. Hydrogen peroxide is one of the reactant needed for heterogeneous catalysis. So we synthesize this TS1 as a heterogeneous catalyst to convert propylene to propylene oxide. This is simple characterization of that material. It shows same at high selectivity. These are optimization at pH 6 propylene propylene oxide is nearly 90%. And this system shows that so if we can convert it into sustainable production, these are a greener process without generating any waste. So this is another paper where we, since I am part of a group where we synthesizing electrocatalysts for hydrogen production from water. So I don't know whether I have time to discuss more. Um, so this is about heterogeneous catalyst on which I am working, different kind of geolites. So these are geolites. I don't know how many of you are familiar with geolite. Geolites are quite efficient catalyst, heterogeneous catalyst. It is used in most of research field, not only petrochemical industry, environmental, agriculture, or membrane waste, or even in detergent, what we are using, geolites are used. So this is a different kind of geolite which I have synthesized during my research. So these are used in different, so especially fugicide or this silicalite waste catalysts are these days used to generate artificial petroleum, or you can say that synthetic petroleum, converting CO2 to longer chain hydrocarbon or gasoline to fulfill the energy demand without relying on fossil fuel. So these are some of the pictures of different geolite use or synthesize in laboratory by me. And so important thing in any synthesis process is to know that synthesis happening. So this is growth mechanism which I reported. So, so research is not like that. You need a fascinating topic, or you can start with simple topic. This is the research I did with my MSc student when I was working at a lovely professional university, just using agriculture waste and transforming it into some adsorbents like carbon, activated carbon. You might have listened about and effectively used or highly used in this water purifier or RO system in your home. There will be a filter where it is full of activated carbon, which used to remove impurity in impurity from water. So research can be started from any point. There are few other material which we use for membrane application, water absorption or purification of water is an important field of research, especially in Asian country where the water supply of clean water is also a big crisis. So desalination or distillation of seawater use material is also an important research. So these are the membrane which I synthesize. So I hope students who are working and they look into their surrounding. Membranes are used everywhere for purification. So we need to think about how we can generate high quality membrane. In membrane, not only active layer but also a substrate play an important role. So these are the nano-size seeds I synthesize. So membranes, these membrane, what I synthesize, these are mainly used for purification of alcohol and separation of organic solvent from this. For example, when we are doing biochemical production of some alcohol, there are many other byproducts. So selective recovery of certain products and membrane efficient techniques. So another research where I am doing, which I discussed earlier, use of QLIX to synthesize gasoline or
body or a healthy material or cancer treatment, killing of cancer. Mainly when you photoinduce cancer therapy, there are ROS. ROS, one ROS is hydrogen peroxide, another is hydroxyl radical. At the same time, keeping healthy tissue safe for the regeneration of hydrogen. This research is ongoing and I am using those photocatalysts for cancer treatment also. These are some results from that study. So as I discussed in the beginning, so when we are working on catalysts, we need to think about how catalytic reaction is happening on that on catalyst surface and its interface, and what are the changes happening in the catalyst during catalytic reaction, whether they are affecting the final product selectivity or yield. So we need some high energy radiation or energy resource or some in situ or Prandtl technique. This is the diagram, different beam lines at diamond light source. There are many facilities which provides valuable information not only about catalysts but also about the catalytic reaction happening. So this is new field for me to open an in situ studies of photochemical reaction, which I am right now working on. So in the last, I would like to thank all my collaborators. I started my research in South Korea with Professor Cho, and photocatalytic work I did with Professor Jan. And now I'm working with Professor Richard at Cardiff University and UP Catalysis Hub. And my present research is funded by the European Commission.
Google Meet માંથી કરવો પડે ને અવાજ.
Thanks.
Thank you very much, sir.
So if there is any question, I am happy to answer, but I could not heard any voice from presentation side. Yeah. Yeah.
Thank you very much, sir. On behalf of MS Science College organizing committee of this
ટ્રાય કરવું.
if any question in participation, please ask in chat box or WhatsApp call. We can use this phone. Yes, yes. Any question from your side? I have. Yes, sir. Yes. Yes. Dr. Pankaj, maybe you are not able to see me, but Dr.
Yeah.
First of all, I would like to congratulate you for such a nice topic. You are really suggested very nice things and can be an inspiration to the future researchers who are there and you have fulfilled the job to inspire young minds in India. So that's the biggest contribution I feel like that you have done through your talk. And first of all, I would like to know that when you talk about that, the production of H2O2 to the genome side, right? You are doing that
Yeah.
science into the genome side. So, can you make a material, carbon material, rich in genome sites, or you just need some organic molecule in it? Can we design any material with a lot of genome sites or phenolic sites and then try that where are we actually?
Yeah, actually, the work I presented that polyheptagenamide, where I use whole cells in that particular field. But after that, I discussed about the two possibility. It means hydrogen peroxide, oxidizing water to hydrogen peroxide, and then reducing H plus ion to hydrogen. So on that I am working. So in that we don't need any organ, but the problem with that is photogenerated hydrogen peroxide get oxidized on that carbon nitride or cyanide contained in that polyheptagenamide. So for that I am using another approach. I am just shielding the carbon nitride surface with some reduced graphene oxide or reduced graphene oxide material or simply that, and loading with some other co-catalyst metal waste so that I can generate hydrogen and hydrogen peroxide at the same time without using any organic. Another approach is instead of using alcohol, I am using some bio-based representative molecule and checking if they are selectively oxidizing to valuable chemical in a simple photocatalytic system. So that in that case, that is also a two-way production. You are generating hydrogen at the same time you are converting some bio-based to another useful products. Yeah.
So it means this strategy is based on some, animals rather than some pure material.
Yeah, actually, pure material is quite difficult for a pure material, even for TiO2 type catalyst. We need to, if we are focused, if we are using biocatalyst, we don't need to hybridize the material. If we are converting um, bio-based, because that will be organic, and if we are selectively converting, that's another work I didn't discuss here. That's under publication. So where we use these carbon nitride waste for glycerol conversion to glyceraldehydes, so that's quite effective. That can easily use uh, proton or H plus ion, holes, and electron can be used for photon reduction. So that's also a good strategy. In that, yield is quite high, but when you are using hybrid system, the yield of hydrogen peroxide and H plus, hydrogen is quite low. So we can, I am working on all the possibilities, but I didn't discuss all those in this presentation, but I only discussed which I.
One last
Yeah.
question, if I can.
Yeah. No. You can ask me as many as questions you want if that conference people they are allowing you. Yeah, I am happy to discuss any possibility. Yeah.
The last question is when you are talking about that fusion production through the charging and discharging through metal and then also the use of that. So I just want to know
Yeah.
that are you really using the sodium ions and then which is converting into sodium
And I hear that that is some exclusive type of reaction. So is it very controlled, very low amount, or how you are?
Yeah, actually, it is very controlled reaction. It is seawater batteries. That anodic part is just hydrogen is reducing in anodic that point cell, and all these reaction is in seawater. I didn't use any artificial water or any electrolyte. I used for that seawater batteries. That is very controlled reaction. There is no thermal effect or any kind of effect. And hydrogen generation is in different in open environment on cathodic side. That is carbon cathode. So it is quite controlled reaction. That was a simple observation because that unit there is a big group or C1 battery group. So it's controlled. Yeah. No, no, that's under temperature control because it is in the seawater that heat transfer happen within the seawater. It's not a small system; it's a big system. And that seawater battery group, because we didn't fabricated seawater batteries, Professor King from that group who is working on seawater batteries, he supplied that point cell seawater battery and prismatic seawater batteries. So those are quite effective, and there is no the main thing with seawater batteries is there is no thermal effect or such kind of things happen as we saw in lithium-ion battery or sodium-ion batteries. So these are quite safe. That's why we propose that this is the safest way to produce hydrogen during discharging. Not we have to make another system to produce hydrogen.
Thank you very much. So
Yeah, yeah.
from my side, now
Yeah.
maybe the other audience have a question. Thank you very much.
Thank you. Thank you.
Any question?
Thank you.
Okay, Bandi.
Yeah. No more question? Okay. Thank you.
Thank you very much. All the participants, अभी lunch ready है और this is a part of training. आपको एक ट्रेनिंग भी दे दी कि रिसर्च में जो कैसा पेशेंस रखना चाहिए और आपने जो पेशेंस रखा है इसके लिए बहुत बहुत थैंक यू. ठीक है, ऑफलाइन पार्टिसिपेट करें लंच. ओके, और 2:30 sit here.
સેટિંગ માં જતા OBS હેલો 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 ચાલુ 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 થઈ ગયું છે હેલો હા થોડું થોડું બસ એમાં જ હાલ જરૂર નહીં જો ચાલુ થઈ ગયું છે આપણે બોલીએ હેલો હેલો હેલો
ટેન પછી પાછું ચાલુ
So now we are in the post-lunch session. I welcome you all to this post-lunch session.
યુટ્યુબ માં ઓનલાઈન
I think you all have enjoyed the delicious lunch over here, but now pay your attentions over here because we are in an international conference. We have called very eminent scientists over here. We are eagerly waiting for their talks. So pay your attentions over here. Today, in the post-lunch session, we have a first. I would like to introduce Dr. Neeraj Gupta, sir. Dr. Neeraj Gupta, sir, is working in the Department of Chemistry and Chemical Sciences, Central University, Himachal Pradesh. He has obtained his PhD degree in 2008 from Punjab University, Chandigarh. Thereafter, he has gained industrial exposure for 3.5 year. He has developed an anti-cancer molecule and has a USA patent to his credit in the year 2010. He was awarded with prestigious Fulbright Nehru Postdoctoral Fellowship for doing research in USA in the year 2011. He has joined academics in Shulini University, Solon in the year 2012. Afterwards, he has been awarded with two more prestigious awards. He was awarded with Department of Science and Technology as a Young Scientist Award in India in 2014, and simultaneously he was awarded by Postdoctoral Award by Chinese Academy of Science. So this is a very prestigious award, top 5 ranked research organizations in the world. For the year 2014 to 17, he has worked like this. He continued his journey of academics in Sholini University, Solon, up to his return to India, and then after he has joined Central University of Himachal Pradesh in January 2020. Recently, he has joined this Central University. He is working in the area of catalysis with exposure to carbon material with a main focus on metal-free catalysis, biomass conversion, electrochemical sensing and their applications in organic chemistry. Till now, he has published more than 50 publications with high impact factor containing journals such as Green Chemistry, Renewable and Sustainable Energy Reviews, and Catalysis Science and Technology.
He's still working on developing user-friendly devices to be used by common people for detecting disease related with neurotransmitter deficiency or glucose deficiency. He has also developed processes for making new chemicals directly from plants that can replace the chemicals derived from petroleum. So, such an eminent scientist with us, Dr. Neeraj Gupta, sir. I welcome Dr. Neeraj Gupta, sir, for his talk on designing of nanocarbon-based catalysts for upgradation of biomass-derived lignin into fine chemical products. Dr. Neeraj Gupta, sir.
Uh, Thank you very much, sir, for the kind introduction. And I would be very happy to interact with the young minds today. Before I really start, first of all, I would like to say thank you for the organizing committee because, I'm always anxious to interact with the young minds. You'll feel this when you'll reach my stage that whatever you do, sometimes you always feel that the things that you have learned in your career journey, it should be transmitted to young generation so that the ideas can keep on growing. So I hope that whatever I have done in this specific area or whatever I'm going to discuss with you will inspire you to do more research into this topic and you attain something good for our country also. So with these words, I would welcome all of you to today's talk, which is basically on designing of nanocarbon-based catalyst for upgradation of biomass-derived lignin and glycerol into fine chemicals. As the name suggests, before I really start, let me analyze my audience and also explain this title. So, how many of you are undergraduates here? Raise your hands. Undergrad, doing BSc. No one? How many of you are doing post graduation? Okay, very few. How many of you are doing PhD? That's really good. So I have most of the people who are really into the research. That's a good point. And how many of you are chemists? I think everyone, or out of chemistry also. Anyone out of chemistry here sitting in the audience? So can I know your field? Which area? Physics. Okay. All of you are also from physics or some other area? Botany. Botany. You also? Okay. So I'll try to collaborate few things also for botany and physics people. I think that people working in physics may know a lot of things about materials, and for botany, maybe you can understand something about the chemicals that we can obtain from plants because you are familiar with the structure of lignin and other composition, the biochemicals we can say. So uh, how can I? Okay, this one. Okay, so as the title suggests that I'm going to discuss nanocarbon-based catalysts. So these are the carbon-based materials that we are going to take chemicals from plants. So I think all of you know that whenever we are deriving chemicals from plants, the formation of petrochemicals is one of the natural process that nature is taking. So I think every one of you are familiar that how petrochemicals are generated from the living stock. I don't want to go into the details of that. But now, because the fossil fuels, they are depleting quite fast. So, and we rely on petroleum industry for generation of lot of chemicals. So we need to speed up this process. How we can do that? Can we really take the chemicals that we are getting from the petrochemicals directly from the plant? We don't want to wait for billion years. So that is the one thing on which lot of chemists they are focusing these days, and few of the things that I will discuss will be based on that. So when it comes to carbon materials, I think most of the chemistry people they know what carbon materials are. So we are using platinum on carbon since 1924. It's a very common catalyst. I think all of you are familiar that we have activated carbon. On activated carbon, we put a metal and we use it for hydrogenation reaction. So that is the initial use where the carbon materials, they find application in chemistry. And every chemist, even the botany and other people, they know because they have studied this basic reaction in their +1, +2 or in graduation. So when it comes to the new class of carbon materials, then we focus our attention towards the new class, which is a nanocarbon material. So when we talk about nanocarbon materials, we think about three types of material: the first generation, second generation, and the third generation of the carbon material. So the first generation of the carbon material is the fullerenes, graphene, carbon nanotubes, carbon nanohorns, and nanodiamonds. So this is the first generation. In the second generation, what we do that these pure nanocarbon materials, where all the carbon atoms are present, are replaced by some other atom. For example, if you replace graphene with nitrogen, few of the nitrogen atom, you create defect in graphene. Graphene is basically a single layer of graphite sheet. So graphite contain multiple layers. So if you are able to, yeah, that's, oh, okay, okay. So this one. Okay. So whenever this is the graphene sheet, we can say that this is the single layer of graphite material. So when all these, they contain carbon atom and no other atom is present in these material. So in the second generation, what we are going to do that we take the pure carbon material. For example, I take a nitrogen atom and few of the carbon atoms, they are replaced by nitrogen. So what will happen? Few of the bonds, they are broken. We create defects. It is not a perfect sheet now. So by creating these defects, the quality for of the material is improved, especially for the chemical transformation. So you can generate a lot of catalyst and the application of this material in various fields. So we have nitrogen and boron doped materials. Here I have shown graphene sheets or carbon nanotubes. So similarly, we have third generation. So where you can take a mixture of these two. For example, this is fullerene, which is grown over nanotubes. And similarly, we have a graphene sheet here at the bottom, and you can see this is carbon nanotube grown over it. So we have a hybrid. So this is one more class that we generally take. So So generally, how to make different carbon catalysts ready for different chemical transformations. So if we want to use the carbon material, this is the one which is ideal. If you see only carbon, nothing else is there. So this is the ideal carbon material. And whenever we do some catalytic conversion, the ideal materials, they have very low reactivity for catalyzing some reaction. So how we can increase their reactivity? So what we can do is, these are the few strategies. What we can do is, as I tell you, one of the strategy, introduce defect by introducing some other atom, for example, nitrogen, boron. What else you can do? You can introduce functional group. So what we can do that we can dope it, we can do surface functionalization. What does it mean? So for example, carboxylic group, COOH group. So you oxidize any carbon material and during the process of oxidation, the functional group, for example, COOH, aldehyde or ketone or phenolic groups, they are generated on the surface of carbon. So that is surface functionalization. So when you are creating these groups on carbon, they become more efficient in catalyzing some reaction. So similarly, when you create a defect, there are some edge defects in the perfect crystalline structure, and those defects, they can also catalyze the reaction. So these are the sites. What you can do, you can also add some metal onto them. So that metal, for example, platinum and carbon. So what you can do is that you can add some atom onto these nanocarbon materials and increase their efficiency. So when it comes to the conversion of petrochemicals, then we again I say that petrochemical is the chemical thing that we obtain in million of years. So now we really aim to develop a process that we can do like quickly. The plant material is dead, and you take the dead material directly to make chemicals. So that is biomass valorization, basically. So what does it mean? That we really need to derive the chemicals directly from the plant without waiting for the natural process that is completed in million of years. So taking useful chemicals out of the plant or animal biomass is called as biomass valorization. So we have different processes when it comes to sustainability or reusable energy. So what you can do, geothermal, wind power, solar power, hydropower, and one is biomass where you are taking this chemicals. So you have a glimpse in the previous talk that how you can use especially this hydropower, water splitting, hydrogen generation, and all. So we are going to touch this green aspect only, where we will see that how we can take the chemicals out of these plant biomass resources. So when it comes to plant biomass, I think all of you know that what it is made up of, right? One is cellulose. We all know it's one of the major component in all the plants. The second one, along with cellulose, we have lignin. It is a very complex network of aromatic compounds. So we have aromatic compounds, we have carbohydrates, along with this we have oil, right? So one is edible oil and we also have non-edible oil where that oil is not fit for consumption, but the composition is almost same because oil is made up of triglycerides. So from triglycerides, what you can take? Glycerol. Along with this, these are other things. For example, xylitol, sorbitol, other carboxylic acids. And there are other series of compounds that are not directly present in plant, but somehow are linked to the plants. For example, the furfural can be derived from cellulose. So it is regarded as biomass derived chemical. Similarly, 5-hydroxymethyl furfural. Remember, these compounds, they are very valuable these days. So if you can make 5-HMF, if you can make furfural from plant, it is really very valuable work because you are linking the fine chemical industry with the biomass industry. And we know that even whole of the cellulose is not even consumed by animals. Wood, which is wasted. We are not even going to use that wood for generation of the furniture. So such type of material, when it is dead, the plant is no more, it can be used for making useful chemicals. So these are the chemicals that are derived from biomass. And now in this talk, I will be discussing few of the strategies where we can use lignin because I cannot touch each and every aspect of biomass conversion. So I'm going to discuss the two aspects where I'm going to discuss that how we can use lignin as a source for making aromatic compounds and also how we can use this glycerol which is derived from the plants for taking fine chemicals that can be derived from glycerol and how we can use it further. So now the first one is metal-free oxidation of glycerol by enriched carbon nanotubes. So you see the title here. What we are going to do? We are going to oxidize the glycerol, which is derived from the plants, for making a chemical which is dihydroxyacetone. So we have not done anything, just oxidize the central molecule. So it's, see the selectivity, you have three alcoholic molecules and here in this catalyst, only the center one is oxidized, the other two remain as it is. So this is the selectivity of this catalyst where we are able to attain with a catalyst which is metal free. So again, the question arises, why metal free? Why metal free is important? So we know that, water pollution, right? And sustainability, they are two aspects that really need to be addressed these days, especially in developing countries. Developed countries somehow they have controlled, but it is a very big challenge for developing countries because a lot of metal is being leaked into water. Water pollution is a very, very big problem. So if we can avoid the use of metals while designing the chemical processes, it is really great. You just stop using metals. You do a process and you give it to the industry, which is not at all using metal. So where is the question of leaking of the metal into the environment? You are generating a clean waste, right? Without any metal. And even if it leaks into the environment, you are at the safer side. No metal is leaked into the environment, and you don't need to struggle with the water purification, doing those expensive RO process and all for making it fit for human consumption. So developing metal-free processes are also required at current time so that we can really attain sustainability these days. So that's why we have emphasized to develop a process which is metal-free and linked to the biomass conversion. So I'm going to discuss the details of this process with you. So first of all, we make a catalyst where we have taken a nitrogen precursor, right, an organic molecule, and with the help of CVD, we make these carbon nanotubes. So how these look? These look like this cup-shaped material. You know, if you see one cup, another stocked on another cup, another cup, another cup, something like that. If you see, it's a cup and one more inverted cup. So we see that it is a tube because hollow from inside, open at the end. So it is we designate it as a carbon nanotube. And also the dimensions are 10 to 50 nanometers. So they are not very big also, 10 to 20 most of them. So they are carbon nanotubes, not nanofibers or some other material. So once we make, you can see that these are very beautiful fibrous structure that we get. Once we make them, we try to know that if nitrogen is there on their surface or not. So how we know it? The process of the characterization of XPS. So for those who don't know what XPS is a technique that tells us that what type of atoms are present on a material. So chemical composition of a material. So what type of atoms are there can be analyzed through XPS. So we do the XPS and we look for nitrogen. So different type of nitrogen, they have different binding energy. So based on those binding energies, what we did that we are able to identify that which type of nitrogen is present on the surface. So we identified pyridinic type, pyrrolic type, quaternary nitrogen as well as NO on the surface of this material. So this uh, really shows that this is the tabular form. I don't want to go into the detail of that, but let me simplify it. From this analysis, we really make sure that nitrogen is there on my carbon material, right? And I make sure that in which forms this carbon is present. So once we know this, we quantify that how much carbon is there, how much oxygen is there, and how much nitrogen is there. So if you see that NCNT 700, 700 is the temperature that we use for making this material. So at 700 degrees centigrade, the nitrogen content is maximum. And then what we did that we perform our reaction. So when we perform the reaction, we did the oxidation by using tertiary butyl hydroperoxide. So it is a peroxide, and this oxidation can generate glyceric acid if it is oxidized. It can make dihydroxyacetone if the central molecule is oxidized, and if both are oxidized, it is hydroxypyruvic acid. So these three materials, they can be formed in this oxidation process. I think the chemist, they know that if you oxidize glycerol, all three OH molecules, this is a very simple oxidation process that can generate these three types of molecules. And when we analyze the different products by GC analysis, we uh, come to know that this is the one which is being made in highest amount. If you see that this is NCNT, because here even the this amount is very high, but the conversion is less. So this material where we are able to get 36%. Again, you see this is not a very high conversion, but because we did this reaction for the first time, this went for a very good publication because we demonstrated this process for the first time, that too metal free. So that was the beauty of the work, that even though the conversion was low, it ended up in a very good journal for publication. So uh, so now the question was to explain that how this reaction is progressing. So I think most of you are familiar with computational chemistry, where we are using the computer to simulate different models where we can calculate the activation energy barrier for the particular reaction. So we take the help of this computer system to know that how our reaction is doing. So the pathway that you are looking here is not being shown after a lab study. We just take the study of computational chemistry to know this pathway. So I'm going to discuss few points about this pathway, that how we discuss the selectivity of this molecule. So if we see that we take this molecule where four aromatic rings are shown, because nitrogen is there and we know that it is something like a pyridinic nitrogen. So we replace one nitrogen here and oxidize it also, because oxygen was also present. So we do oxidation at 2 points, one adjacent to this and one here. So the one which is adjacent to it, this is the cyclic pathway, and where it is here, it is shown like this. So when we did this study, we came to know that this pathway, where this site and this site, they are oxidated, somehow are giving us the good selectivity of the product. So the adjacent site, the oxidation, the conclusion of this story was that if you have a pure pyridinic nitrogen, it may not give you the selectivity. The selectivity can be attained only if the adjacent oxygen atom. So here both of they are required, but here the second one is here. And so when this type of structure is there, it was giving us more selectivity as compared to this pathway where the second oxygen is here. So oxidized adjacent CO group to the nitrogen atom were found to be very active for this oxidation process, and we have identified these groups in our XPS study also. So this, we again, the catalyst is good if you can reuse it. So we were able to reuse our catalyst for 8 cycles, where almost same catalytic activity was obtained. So 36% conversion was there everywhere. So this catalyst was nitrogen containing CNT, was found to be very good for oxidizing plant derived glycerol, where it was able to selectively make dihydroxyacetone out of 3 possible products. So the selectivity of this catalyst was also very good. So it has a very good use in biomass industry. So along with this, now we targeted one more compound which is derived from plant biomass, and that is lignin. So this is the lignin structure, and as I tell you that this can be broken down, all these chains, if you see these fragments. So if you are able to break these fragments, you will get different types of compounds. So these compounds can all are aromatic if they are not hydrogenated from the ring. So if all are aromatic, you can get hydrocarbons such as toluene, you can get phenol and phenolic products where ether or other compound substituents are there. So all these are phenolic products, pure phenol or toluene. So these are the products. And if even the ring is hydrogenated, you can get cyclohexanol also as a product. But because I don't get any cyclohexanol, or very less cyclohexanol, so I don't show it here in this reaction. So the reaction that we study here based on carbon based material is the one which we call as hydrodeoxygenation. So we really need to understand before we really go into the details of this process. So what is hydrodeoxygenation? As the name suggests, you are using hydrogen deoxygen, oxygen removal. So you are using hydrogen for the removal of excess oxygen content present in lignin. So if we are using hydrogen for removing of excess oxygen content for the generation of different chemical compounds, this reaction is called as hydrodeoxygenation. So again, when I talk about sustainability, I say that metal-free materials are very good. But again, the second challenge is, can you do hydrogenation without metal? Anyone? All of you are research scholars. Anyone? It's better to interact. Do you know that can you do hydrogenation without the use of metal? For example, platinum, palladium, nickel. Can you do without them? No, it is very challenging. So though these days we are working in this direction also, I'm not going to discuss. I have done one process where we have achieved metal-free hydrogenation also, but that's not a part of this discussion. So I'm not going into that detail because doing a metal-free hydrogenation is really a very, very challenging task. So in order to do the initial work, what we do, we choose a metal which is ruthenium and also palladium. And what we do that we choose these metals and we deposit the nanoparticles of these metals onto the carbon surface, and then we perform the hydrodeoxygenation reaction. So I'm going to discuss two such strategies in this work. So the first work where we have used palladium. So what we do that we take palladium and different carbon supports as I show you in the first slide. So we take activated carbon, very old material that we are using from 1993 that all the chemists are using. Then we are using ultra dispersed diamonds, or we also call them nano diamonds. It's a diamond structure and nanometer range. And then we have also used carbon nanotubes, and these are the oxidized one. These are pristine. Pristine means we don't use any oxidation process as received. Along with this, so we take these four materials and deposited the metal. So how to deposit the metal is another task. So metal ion is converted into metal. So how we can do that, students? Show your participation. How you can convert a metal ion into a metal in a zero valence state, which is the process, very basic chemistry. Are you not understanding? I'm not understandable. Yeah, it's a very simple reduction. You are doing reduction. So we can do reduction by molecular hydrogen or as well as some reducing agent, sodium borohydride. So generally the reduction with gas is preferred because it does not lead to any metal ion impurities which are deposited on the surface. So we are always safe that no other metal is in the catalyst, only the one that we have added is present on its surface. So for example, we use palladium salt, so we were sure that only palladium is the active component, no other metal is there. Because if you put sodium borohydride, there is a competition between sodium and palladium, and people always question that what's the role of sodium? You have used sodium borohydride, prove that. So it increases your, complexity of a reaction. So in order to keep the process simple, we use molecular hydrogen for the reduction process, and we just take a palladium salt, palladium nitrate or palladium chloride, and a very little amount. We do not need excess of it. For example, if you have 100 milligram of your carbon material, even 2 to 3 milligram of your salt is enough for doing the reaction. So see how much low amount of metal you require. So you absorb it, you make the catalyst, and then we study that what type of metal nanoparticles have been deposited on it. So once we know it, we characterize it with the XRD also. And here we can get information, for example, that what type of sp2 sp3 carbons or palladium, the state of palladium, whether it is palladium metal or oxidized palladium present on the surface. So we come to know that small amount of palladium oxide is also present. We haven't used it, but still it is there on the catalyst. So we again say, because we are heating it, and whenever you are hitting it and you just stop your reaction, sometimes when you remove it into the air, small amount of air always get absorbed onto the surface, and somehow this leads to the formation of palladium oxide, which is unavoidable. So really getting no oxygen on your catalyst surface is also a very challenging task, or you have to be patient. Because I was in initial years of my research when I do this, and when sitting in the lab for maybe 24 hours is a very tiring task, and you are, oh, my reaction is done. It should be cool very fast, and you remove it, and then oh, but just by doing one mistake, not waiting for 1 hour, you get palladium oxide. So again, I'll say if you are going into research, be ready to spend a lot of hours into. I'm not discouraging. Whenever you are going into research, the basic thing is that you should always be ready to spend maybe 10 hours, 12 hours, or maybe my longest reaction that I have performed is 40 hours. So how to perform that? You really have to plan a strategy that how you can continuously run a reaction for 40 hours. Maybe two people are required who can work even in the night. You just have to monitor it because sometimes things like explosion or fire may happen. So you need an assistant, but sometimes you really have to do it if you really have to attain good results. So be ready. I'm not discouraging. But the thing is that once you are mentally ready, you don't feel the things very mentally tiring. Otherwise, you are like, oh, after 6 to 7 hours, you always feel mentally tired. Oh, I want to go out, because we are in a habit of college hours or university hours where the classes are done and we immediately rush to our home. So this type of a culture does not prevail in research or even industrial jobs. So again, we study the surface composition, and here we try to know that what is the chemical state of palladium. So there were two types of palladium: palladium ions and palladium metal. So we calculated the ratio of these two metals. Along with this, we also studied different type of functional group. As I tell you that when oxygen is present on carbon, it is present as a carboxylic acid or ketonic group or alcoholic group, OH group. So we identify these type of groups by XPS spectroscopy. And every catalyst has a different combination of all these things. We continue the study. So where we use all these catalysts for hydro deoxygenation reaction. So these are the content we tabulated. So I'm not going into the detail. You can just see that how much palladium is different on every metal, palladium ion and palladium zero, right? Here it is different. Palladium 2 positive is also different. So here are the functional group which is different on all catalyst surface. So then we did the reaction. So don't be scared to see this table. You know, you really have to spend. Let me tell you the story behind this table. I'm sharing my research experiences also. So you can see the entry from 1 to 26. So it appears that you have done just 26 reactions. Believe me, this is triplicate result. Means 3 to 4 times we have taken a reading. It means almost 90 to 100 reactions. Every reaction is not fruitful. You know, sometimes we just take that how many times you are able to reproduce this. So when you are, for example, 2 readings, they matches. So that is the value we are going to report here. This is how you do. This is how you do work, right? And again, I tell you, if you see the time, reaction time 8 hours, 19 hours. See, and so this is uh, 19. I think there was one more. I don't share here. One reading was also there for 24 hours, more than 24 hours. So what we do is that we perform that we take the catalyst, we take the lignin, we put it in a reactor where you can purge the hydrogen, you heat it or you don't heat it at room temperature, and you analyze the products, that what are the products. So before doing on the carbon material, we just take organic molecule vanillyl alcohol. So vanillyl alcohol is one aromatic compound where you have OH, OCH3 groups attached to it. So that we really want to see, because these are the functional group in the lignin also. So we just want to do before lignin on some molecule, organic molecule, where such type of reaction, which is very close to lignin, can be studied. So here we see that the catalyst was able to convert this vanillyl alcohol to 2-methoxy 2-methylphenol. So here only one methyl group was generated and phenolic group was not released. So what we concluded that this catalyst was somehow converting CH2OH group into alkyl group, but not the phenolic group into benzene. So that was the one thing that we come to know from this study. So again, we have three materials: nanodiamond, carbon nanotube, activated carbon. So we were not sure that if support is playing some role in this work. We just find a correlation that whenever there is palladium content which is increasing, the HDO capacity is also increased, hydrodeoxygenation capacity. But no such correlation was observed for any of the functional group or the surface. For example, what nanodiamond is doing or what the activated carbon is doing, we were unable to get any information from this work. Even though we were able to publish it in Journal of Energy Chemistry with impact factor 10, but still this was the limitation that was there in our work and we were unable to explain it. So finally, what we did is that we try to explain the mechanism of this reaction. So this is another work that we have done. So I'm not going to into detail of this slide. So here, this is our another work that we summarized in a review, and we were again fortunate enough to get a good review. This is uh, renewable and sustainable energy review with impact factor 17 currently. So when we did this, we proposed two types of mechanism. One is ionic and one was free radical. So these are the two mechanisms that we propose. So this is our work that was published that I'm discussing with you. But this is some other work that we have compiled in our review. So this is not our work, but from the literature, we have designed this scheme in our review that we have published. So most of the people, when they have done the hydrodeoxygenation reaction, everyone is confused. Even today, we are confused. We don't know whether it is ion intermediate driven or some free radicals are involved in this reaction. So there is a confusion because the moment you know the mechanism, maybe you can better design a catalyst. That is the purpose. That why we really look into the mechanism. Because until unless you don't know the mechanism, it is really very hard to hit the exact catalytic site that can lead to this process. So here we say that if you have ion, so how those ions, for example, a metal ion, so that metal ion can coordinate to these groups and these somehow can split. So when ion is coordinating with the ether bond, so will it promote homolytic or heterolytic cleavage? Students, yes, zinc ion into positive state. If it is coordinating with ether bond, will it promote homolytic or will it promote heterolytic cleavage? Any guess? Yes, because it is iron, so it will try to take both the electrons and probably promote the heterolytic cleavage. So heterolytic cleavage will initiate the formation of ions and not the free radical intermediate. So this was the proposition that we proposed, that if people are using some ions, because there are a lot of catalysts that uses iron, and that ion somehow promote the heterolytic cleavage and reaction is progressing through the ionic intermediate. Whereas when you are using nanoparticles, metal in zero oxidation state, for example, nickel carbon, platinum carbon. So all of you must have studied the mechanism of hydrogenation. So what is involved in this reaction? Free radicals. It is proposed. Mostly they homolytic or heterolytic, both the cleavages are proposed, but mostly it is free radical which is generated. So when you have a metal, so it is adsorbed, hydrogen is adsorbed, and this hydrogen then generate a free radical, and then free radical interact with these molecules where this ether linkage is attacked by those free radicals, and definitely a free radical will generate another free radical. You know that chain initiation, chain propagation, and chain termination. So the conclusion is a proposition. I'll say we don't do any experiment here. We do here what we do, one experiment. We take radical quencher. So I think you know what are radical quenchers, students. What are radical quenchers? How to decrease the rate of a photochemical reaction? Photochemistry पढ़ी है ना? Have you studied photochemistry? How you do radical quenching? For example, you are adding a peroxide, right? So when you add a peroxide that react with the radical, that itself is not reacting with any of the reactant. So that is radical quenching. So we add a radical quencher and we observe that HDO reaction, the rate of the HDO reaction decreases very rapidly. So what does it mean? Somehow radicals are involved in this reaction. So this we have proved. But again, we fail to show that uh, it is 100% radical, because it should be zero, but we don't never get a 0% conversion, even when we use the excess of the radical quencher. So what does it mean? That both the things are there. Because if metal ion is there and you are not able to remove that, you are unable to stop that ionic mechanism. So whatever work we have done again lead to the indication that both the mechanisms, they are prevailing on the catalyst surface, the radical ionic mechanism as well as the free radical mechanism. So after doing it on vanillin, our next task was to study that can we do it on a lignin that we get from the plants, and that was the next question. So we take this task and then we isolated lignin from plants. So we take a plant which is pinus in the region, because Solan area we have a lot of pine trees there. So that was the reason we take a pine, because lot of waste is generated in that area. So we will be able to show by that process that the local waste which is generated in the region can be used for generating some chemicals. And also corn cob. So I think whole of the India, everywhere you have this corn cob. So we just take the corn cob and also extracted lignin from this corn cob. So we have these two lignin, and one we purchase from the market, just to be sure that what will be our result. Because we really want to be sure that there is no error in isolating the lignin from these two plant source as well as the one that is available in the market. So we take three lignin and again started with the model molecule. One more. After vanillin, we just also tried this guaiacol, and this time we replaced palladium with ruthenium, and carbon nanotube. We just focus on one carbon nanofiber. We don't make a lot of catalyst. So what we did, that again we characterize that what type of catalyst it is. There are metal particles, and these are the ruthenium metal is also present on it. So we decide, this is HR-TEM analysis that show that what is the morphology, and with this mapping, elemental mapping, which is different from for every element, you know that which type of element is present on its surface. So we were able to see this ruthenium. It has carbon because it is mainly carbon material. There is oxygen also, if you see, and also we can see that ruthenium, and this is a combined image. So this is very few you can see here. Maybe it is not visible. Yeah, here it is not visible. It is very, as I tell you, it is 2 to 3%, not very high amount. So you really on this slide, maybe you are not able to see those particles of ruthenium, purple color, but it is there on the surface. Again, we did the XPS to confirm that if it is ruthenium in zero state or oxidized state. So we found that both are present there. Along with this, we also see that carbon, different type of functional group are present through carbon as well as oxygen spectra. We did the IR spectrum and XRD. I'm not going into the details, but the main thing is that we make sure that ruthenium is in the present is present as ruthenium 0 or oxidized RuO2 form. So now coming to the test into the laboratory, we again performed reactions. We performed, so this is the one that I have done in India. The previous one I did in China. So this is the one that I have performed in India upon in Shulini University. So here we again did a lot of reactions, multiple reactions, and we were able to get conversion in 24 hours, that too at 80 degrees centigrade. We don't have the facility to take the temperature up to a higher range, so otherwise conversion could have been better. So maximum temperature we were able to attain was 80 degrees centigrade, and we performed that for maximum 24 hours, and even we tried in 40 hours, but not much difference there. Maybe the catalyst was saturated by that time. So maximum conversion was 79%, where toluene was 78%. If you see the reaction, uh, this is the reaction. So see, OH, when the toluene is generated, it means OCH3 methyl. This oxygen is removed. This OH is removed. See here, as a very good thing is happening. It is removing all the oxygen linked to it and making the hydrocarbon. So we were very excited from this result, and we see that what will happen on lignin. So then we take commercial lignin and did the same thing with the lignin, and we use GCMS technique to identify these products. We really struggled a lot to identify. So what we identify, I'm going to share these results with you. So we have phenol. This is also phenolic intermediate with OCH3. Same. Here, one alkyl is also there, and almost the same thing. Few alkyl chain molecules also. Now the question was how these molecules they are obtained. Because lignin I show you was aromatic. So this we can understand that there are side chains linking the aromatic molecules. So these side chains, when they cleave, may result in the formation of this type of molecules. And how these are generated? When the aromatic compounds, they are opened up, these can form these straight chain compounds. So these are the different compounds and we calculated their yield. So the maximum obtained was this phenolic compound, which is almost 31% in commercial lignin. So coming from commercial to one which is we isolated from the corn cob, the lignin that we get maximum was this toluene, right? So it is almost 10% and others are very less. And also almost the same thing. This was something new that we get, but others are more or less, they are same. So when we perform it with the pinus bark, then again we get almost 12% of this toluene and other hydrocarbons and also the straight chain analogs. So we are able to get almost different variety of chemical compounds from lignin that are hydrocarbons, right? Heterocyclic compounds, phenolic compounds, ethers, and even straight chain alkanes from lignin, which is very good. So if you keep on doing this process, what we are able to demonstrate that you can use the plant lignin directly to form phenolic as well as straight chain aliphatic compounds. So this is one of the significant, it means that you do not really need to go for petrochemicals. Directly use lignin, use the catalyst, design a catalyst, and directly the only thing is on which we are working right now because it is a mixture. So now we are working on a process where we can get individual component as a pure component so that they can be supplied further. Right now, we have attained a stage where a pool of such chemicals is generated. So, so this is the HPLC graph, if you see, where we have shown that where the peak of these compounds they are obtained and compare their mass spectra. So already discussed this in the, so this is the recyclability of the catalyst. Again, we tested it up to 6 catalytic cycle. And the question was, still there was a question whether ionic or radical mechanism was prevailing. So we did one more attempt. Okay, let us try this time with some other models, computational study, because studying it directly in the reaction is a very challenging task and you really need very sophisticated instrument. For example, in situ ESR studies, and unfortunately we don't have access to such type of instruments in at least in my place. I'll not say India, maybe they are there in IITs or IIC, but at least in my place, I do not have access to. So therefore, that's why I again switch on to computational models. Let us see that what computer has to say for designing this process. So we design a model, carbon nanotube, we oxidize it, created these functional groups, and we identified where the metal is located. So this identifies that whenever ruthenium is present in the zero valence state, it sandwich itself, it always moves away from the functional group and prefer to go above the layer, somewhere in between the groups. But it is not coordinated. We can understand this also, you know. Iron can form a coordinate bond, but metal in the zero valence state will not prefer to do that. It's something like that. So then we, based on this, we try to see that how the solvent will interact or what is the activation energy barrier for different molecules. So we started with the molecule guaiacol and we find that it is absorbing onto the carboxylic group, and when it is present nearest to the metal center as usual cleaves the hydrogen, and this hydrogen when cleaved prefers to go in the radical form here because we studied both that if it is heterolytic cleaved here, what is the activation energy, and when it is homolytic cleaved, what is the activation energy. And computer says that when it is homolytically cleaved, the computational energy, the activation energy is less. So we propose that it is the radical which is preferred the most again. But if the radical pathway will be blocked, it will be forced to go for the heterolytic cleavage. So here again, we were unable to propose the just only one side of the catalyst. Again, we say that both the mechanisms are probable, though the radical mechanism has the higher end. So if every facility is there, the reaction will definitely move through the involvement of the radicals, and where these radicals finally it will again be cleaved, and this cleavage finally, this step we really need to understand right now, because uh, we were able to get a toluene with a very low activation energy, but what type of intermediate is involved in this step is still not clear to us. So right now we are working on this area, that if it is really taking away the oxygen, is it totally detached from this molecule, or it is a concerted step? We really need to propose it, and this is a part of our future study. We are just doing it right now, and we'll propose it in our next publication. So with this, I'm going to conclude my talk. So what we have done, we have done a metal-free oxidation of biomass-derived glycerol that you can get from non-edible oils and convert it into very useful chemicals. And the chemical that we prepared here was dihydroxyacetone. So when it comes to the mechanism of that reaction, we say that pyridine nitrogen group in the carbon nanomaterial are responsible for that, and they can show activity also when their adjacent carbon is oxidized in the form of CO. That was another. So when it comes to hydrodeoxygenation reaction, we say that active metal component is really necessary. So you cannot perform it without metal. You need some metal that can cleave hydrogen, for example, ruthenium or palladium. So we are trying to do it without metal. You need very sophisticated techniques, and maybe the young mind sitting over here can propose something to do HDO without metal for lignin. Believe me, this is going to be very big boom in the industry if you can do that. So with this, we say that we were able to link this process to the plant derived lignin that we really isolated from the area where we live, and we demonstrate this process on two lignin which we isolate from pinus as well as from corn cob, and we were able to get a pool of various compounds that contain phenolic compounds, aromatic hydrocarbons, and even straight chain uh, alkane derivatives. So still they have oxygen, not the pure alkanes. For example, straight chain carboxylic acid esters were present in the pool. So with this, we were able to show that the carbon materials, they can be used for designing sustainable metal-free catalysis for the biomass conversion as well as for the lignin conversion. That too is sustainable, but again, if we can make it metal-free, would be a great contribution to the chemical society in large. So I'm really thankful to the organizers, committee members of MN College, Visngr, for inviting me for this talk. I'm really very happy to interact with all the young minds over here. And along with this, uh, I'm really thankful to Fulbright Commission USA that introduces me into the field of biomass conversion, because my project that I have written for Fulbright Fellowship was on biomass valorization that I get in 2011. And simultaneously, carbon material, I'm thankful to Chinese Academy of Sciences, because uh, I write a project by collaborating these carbon materials to the biomass valorization that was awarded to me for 3-year research in Chinese Academy of Sciences, Shenyang, China. And Professor Dang Chang Su, who's no more in this world, but I learned a lot of things from him about the carbon materials. And these are my collaborators who are still helping me for doing a lot of work, because whenever I'm stuck here in India and I say, oh, I am not getting anything, so they come for my rescue. Okay, I have computer, I have good computational things, so you send me your models. And Alberto always say he's my postdoc fellow. So we both were doing postdoc with Professor Dang Chang Su. So he always come to my rescue. Oh, I have a lot of facilities in Italy, so you just send few of my materials. I would be happy to test this. Otherwise, it's really very challenging to do this biomass conversion sitting in India, where the facilities are almost at par with the MN College, Visnagar. Believe me, maybe you must be feeling that I'm in a central university. but my university is at par with your college, no difference. Uh, and then these two universities that helped me to get a position when I returned back to India. The Shuli University offered me a job immediately upon my return to India, and now I'm continuing my journey of research in Central University of Himachal Pradesh. So these are the key publications that I tell you. One is Chemical Engineering Journal that we recently get. Uh, and then this is Advanced Material Technology. Then we have Sustainable Renewable Energy Reviews. Also, Material Today Chemistry. Uh, and I'm very thankful to these three journals that have highlighted my research into their front page. So this is really a great honor for me. I hope you can feel that how a scientist will feel if his work is highlighted on the research front page of the research journal. So this is Chem Electrochem, my biosensor work, Advanced Material Technology, Wiley, Germany. They highlighted one of my biosensor work recently. This is very recent paper, and Chemical Engineering Journal, where we get a cover page article this year. Uh, and along with this, you are not alone to do all these things. Your students, they always come to your rescue. So when I come back to India, I am fortunate enough to have a good team. So from 2017, 16 onward till now, my seventh PhD students will be out next year. So six they have completed. So that's a list. Now these are my current PhD students in Central University of Himachal Pradesh, and this was my team in Shulini University that have done very good work on biomass conversion, especially Ashima, Vineet. They have really done very good work on biomass conversion. So with this, I thank you all for being the patient listener. Thank you very much. And I would welcome all the questions from your side.
Yeah, actually, in the post session, we are learning very great. So I'm giving just 5 minutes for any questions if you have.
Yeah. Yeah, that's what I tell. When you are saying that a carbon material, it looks same. You are unable to distinguish if it is carbon, if it is nanotube, or if it is a nanodiamond because everything is black, a black powder. So analysis, as I discuss TEM, TEM images because they really can show you. I show you the images. If it look like a tube or it is a diamond, so you really have to go for microscopy along with XPS. So these two analyses can really tell you that if really that site is there. Without those analyses, no, you cannot tell it. So you really have to go into the details. For example, if you're an organic chemist, we cannot say that this is a compound without doing the NMR and IR analysis. So similarly, you cannot tell that if it is a nanomaterial without doing TEM and XPS. Okay.
So in your X-ray result pattern, yeah, previous slide, X-ray diffraction pattern.
Uh, this one?
This one.
Okay.
This one. So these are not identified. It is related to particular millet acid. So the chemical of the particular element.
Oh, okay, okay. So basically, yeah, because it was a mixture, and we basically just try to identify if that is lacking. I do agree. Because our focus was just to see that if it is a palladium oxide or palladium. So we could do that. Yeah, next time we'll see that if we are going to do that, we can do that for Miller indices also. We'll take that suggestion. Thank you. Yeah, sir.
Very interesting lecture.
Thank you, sir.
One question which is of my interest always, can the selectivity be changed with respect to temperature here? Because when we get so many products, linear change, aromatic, heteroaromatic, so if the temperature changes, do we have selectivity?
Yeah, that is this is one of the very recent work. I just get publication of the last work that we get this month itself. So that's really a nice question and aspect that we really would like to probe. So the practical challenges that we are facing right now is the deficiency of a very good instrument. So as I tell you that I do not have an instrument that can go beyond 80 degrees centigrade. So I'm trying to get one good instrument from my university, and frankly speaking, from 2 years my file is not moving at all. So if they give me that instrument, I would be happy to do that. It is always better to study it up to 250 degrees centigrade, because the moment you will increase the temperature, definitely why we have still the oxygen, because we were unable to attain that temperature. The moment we'll raise the temperature maybe 150, all the oxygen will start becoming less and less, and the content of hydrocarbon will increase. You are very true, but this is something limitation of the working facility. That's it. We would be happy to do that. I'll see how we are able to attain that.
And one small thing, is there any scope of microwave?
Yes, again, but microwave, the two things will be, as I tell you, that it will be great if we can do it metal free. Because sometimes when we go for metal, I'm always afraid that metals and microwave combination, somehow the orientation and all those things, they are something problematic. So therefore, uh, it can be studied, if you can use those metal nanoparticle in a microwave reactors. But again, you need some collaborator who has a very good microwave reactor, to whom you can supply these materials, and then we can analyze at what microwave radiations can do. But that's also a good idea that we can study. Thank you.
Thank you so much.
Thank you.
Thank you, sir. And we hope that today is the very biggest problem is there for Delhi. Parani of this Haryana, which is creating a problem for Delhi. I think with your research work and the team which going to approach in this direction, maybe some fluoride and other things, or liquid will be converted into petrochemicals within a few days, and we can resolve that problem too. Maybe not one, maybe just some
Yeah.
two other things.
We need biorefineries. Yeah.
How much there? So we hope so. Thank you, sir.
Thank you, sir.
For your what. Uh, I would like to request Principal sir to facilitate you with momentum and thank you. And the certificate we just given to Dr. Gupta sir by the president. Thank you, sir.
Thank you. Thank you. Thank you. Thank you. Thank you, sir.
First, actually, I went to the area. Dr. Kiran Joshi and Dr. Poonam Lanjil certificate, sir. The momentum.
Hmm. Oh, mhm.
Hello. Good afternoon, all. On behalf of International Conference on Recent Progresses in Chemical Sciences, MN College, Visngr, I am Sangeeta Sudhar from Chemistry Department, Assistant Professor in MN College, Visngr. Now, today I would like to welcome to you all the delegates present are here, faculties, and all my dear participants. Now, today's speaker is Dr. Rajesh Kumar Pathak.
who presenting their presentation on online. Dr. Pathak received his undergraduate degree in chemistry as well as in biology from the University of Rajasthan, the master degree in chemistry from the Jawali University, and he enrolled for the PhD under the guidance of Professor C.P. Rao from the IIT Bombay. He worked on the synthesis and biointeraction aspect of proteins, enzyme mimic supramolecules. He also joined the Ohio State University in 2015 for the postdoctoral fellowship, and he is also awarded for the fellowship, Ramanujan Fellowship, and as well as Early Career Advanced Research Award from the SERB DST. And nowadays he is working as an assistant professor in the Department of Chemical Sciences, Indian Institute of Science Education and Research, Behrampur. Dr. Pathak's research group is developing prodrugs and metal prodrugs conjugated and their nanoparticles for the application delivery of the cancer treatment. And now today's topic on this session is combination therapeutic prodrugs and nanoparticle based on organic or inorganic scaffold for cancer treatment. Now I would like to welcome to Dr. Rakesh Kumar Pathak. So then now we will start the session. Thank you.
Can you hear me? I'll share my slides. Hello? Yeah. Okay. So good afternoon, everyone. So today I'm going to talk about a topic in detail, and this is different because I cannot like see you people, but it's fine. I hope you guys can see me. So today's topic is combination therapeutic products and nanoparticles based on organic and organic samples to cancer treatment. And actually, I couldn't hear a lot of you what you were talking, but just want to convey my thanks to Dr. Suresh and all the organizing committee for inviting me to share the work. And thank you all the audience who are listening this now. And please interrupt me. You can call me. Please, you can call me if you find my presentation not visual. All right. So I'm going to talk about use of metal iron and the topic which I said that organic and inorganic. So if you look at this periodic table, which I have titled as a traditional periodic table, so what does that mean? That every metal ion which you can see here, yeah. So you can see in this periodic table, every metal ion which is being presented in different colors has some another role, and most of them has some role in biological concern. And these roles can be divided into different categories, like if I'm more concerned about the medicinal property. So you can see the ones which are actually having blue filling, they are actually utilized in different therapies, and some of them which are having orange filling, right?
those are utilized in diagnostic purpose. So like that, you have different classification, and we can go on in understanding each McLaren. But today I'm going to discuss few of them. One of the McLaren. And before I start, I just wanted to uh, make you understand, and I think we all know that why McLarens are so specific. So when we go in deep understanding that basic question, that why McLarens are so special and why each McLaren can be very unique to its own. So there are two properties which are like textbook material starting from I think 10th class, that most of the McLarens, especially you can take tungsten metals or maybe some other McLarens which are having variable oxidation states. And these oxidation states is not just for the namesake that they have multiple variable oxidation states, but they contribute a lot in their binding nature towards the ligands, and those ligands can be organic molecules or any other small molecule, which we will see in few slides. And the other important thing is when the oxidation state changes from one oxidation state to another one, the property of their binding towards that particular ligand also changes, right? Because the basic concept of charge density changes and its interactive nature will also change. And related property of McLarens is they have structural diversity. So if you take a lot of McLarens and then if you want to compare with similar ligand, you will find that individual McLarens have different structural topology, because what you see is from the outside how they look when they are actually covered with all sort of ligands, right? And another important thing, if you can take one McLaren and in different oxidation state, it can also show lot more different geometry, like which are some of them are shown here. But it's not exclusive, all of them which I am giving. But I just want to emphasize that why individual McLaren is so important as compared to if you look at any organic molecule, because these McLarens can have distinct nature, and each one can have different nature when it is in the different oxidation state, and it can bind with different ligands to have different geometries, which can have different biological implications. So today, I'm going to use them, some of them, as I said, in the biological property, one of the medicinal property, and I'm going to discuss one of the McLaren, which is platinum. Okay, and the topic which I'm going to cover is the use of platinum products in cancer treatment, right, and the different development which we have so far done. So when I'm moving towards their role in as an anti-cancer drug, let me just switch gear with and then tell you about what is cancer. I'm sure many of you know what is cancer, but just for our understanding further, let me just recall this cancer by giving some analogy. So you can assume that cancer is a group of diseases. It's not one disease. It is like group of disease where different type of disease comes in a similar characteristics, and you put them in one category, broad category, which is cancer. And what happens in this particular disease, that the common feature is they will have uncontrolled cell division, and that cannot be controlled. So the analogy which I want to give is, you can assume that you have some sort of cut in your skin part, right? And that cut will create some gap in between the tissue of the skin, what you can see as an analogy. And now the cells around this wound, around this, whatever cut has happened, will get the signals that you have to fill this gap. So they will actually divide faster than the cells which are not in this wound region. So what will happen, that you will have quick healing of this wound, and then you can say, okay, wound healing has happened.
that is the process which is happening not only when you have a cut, but when you want to replace the old cells to the new cell. Okay, and that cell has to come from this process which should be almost 100% precise, right? Or I can say 99.999%. But what happened in cancer, that this one cell which actually get the signal to divide, and it also get the signal now the wound is healed, we don't have to divide, so this will become like the normal cell. But in case of cancer, when the cell is dividing, one of the cell, for unfortunate reason, what happened that it has some mutation, and this small mutation will actually allow this cell not to take the signal from the cell signaling process, not to divide. So it will actually keep dividing, right? And when it is keep dividing, it is not taking signal to stop, then what will happen? You will have multiple such cells, and each cell has this mutation that you don't have to stop. So it will have multiple divisions, and this multiple division will give you unwanted, uncontrolled cell mass, and this cell mass is what you can categorize as a tumor, and which will have this mutation, and that's what it will be malignant tumor. Okay, so what we are going to discuss today, that how platinum based combination therapeutics can be utilized, and I have taken one particular example of prostate cancer today. So we will have concept of combining cisplatin with another drug which is called aspirin, and I will tell you in a couple of slides that why this particular aspirin molecule was chosen, and then there are in vitro studies and another advantage of the addition of these formulation into the nanoparticles for animal studies. So before moving on to what we have done, let me take you to the journey of platinum drugs. So you will obviously have questions. I think many of you might be knowing, but those who don't know, let me tell you that the platinum drugs are, you can consider a category of drugs which bind with the DNA, and these platinum drugs, basically nowadays a couple of them are there. Initially they were best characterized to treat testicular cancer, and nowadays they are also labeled to treat variety of other cancers. But if you look at the structure, and those who are inorganic chemists in the audience will see there is no organic molecule as such. Organic molecule means you categorize based on carbon presence. So here you can exclusively say that this is the inorganic based drug, and because this was the first of its own type of drug, that's what we can also categorize this as a first and best known inorganic based drug. And this was discovered by Werner Rosenberg in accidental discovery. You guys should go and read about it. It's a very interesting story of this. I will not go into story, but I'll give you the timeline, which will actually provoke our thinking that the use of multidisciplinary field. Okay, so as a chemist, Michael Pyrenon, he synthesized this compound, which we now call it as cisplatin. He doesn't give the name as cisplatin, because whatever compound he synthesized that was having the similar structure, which was which we know at later stage. But he synthesized this compound in 1845, so almost like more than a century later, more than 100 years, Werner Rosenberg, as I showed in the previous slide, he discovered its anti-cancer role in 1969, and in 1978 only we could use that to treat human cancer. So you can see the gap of more than 100 years, just because the person who synthesized couldn't directly utilize, couldn't directly correlate that it might have its use. So that's a big gap happened, and it was just sitting lying on either in the publications or on the site. So moving on, correlating further the importance of platinum-based drug. So even nowadays, if you see and compare the use of cisplatin in clinical trials as compared to other drugs, which is called paclitaxel, I have just put the short form here. So if you compare at this stage, the utilization of cisplatin versus the utilization of paclitaxel in the clinic, you can see cisplatin is still dominating what it's used. It means it is still having a potent role, and it can actually be modified, or it can be looked at what are the problems, why we are developing more and more other type of drugs. Why don't we relook about the well-known drug that we discovered like that? So, having said that, let me tell you the mechanism how cisplatin works. I think from there we will also know what are the problems with the cisplatin. So, if you can see the mechanism of cisplatin is that it is in the circulation as a cisplatin molecule, one of the smallest based molecule, and it can go inside the cytoplasm, inside the cells, and when it goes inside the cell, it will have immediate effect of water as a nucleophile, because the chloride concentration inside the cell is different than the outside cell. So because of the difference in the chloride concentration, it can easily get replaced by the nucleophilic water, and then eventually you get positive charge on the nucleus. So this positive charge is not exclusively on water. You can assume that it's on the complex. And now this positive charge containing complex, which is having labile water, eventually it can remove 2 of the chloride and can have 2 plus charge. It immediately interacts with the DNA, and in DNA specifically it binds with the guanine and 7 position. Guanine is a base which is present in the DNA structure. Also have platinum adducts, and these platinum adducts are recognized as a something which should not be there in the normal cells, and the cell signaling denotes that now this particular DNA is in the fault, and it has to either repair, or if it is not getting repaired, then cell has to suicide. That is called apoptosis. So cell itself dies from its own signals, but now you have a faulty DNA, and if you actually replicate this faulty DNA, you will end up having some sort of mutation. So what will happen? Cell will die at this stage, and that's how you can achieve the anti-cancer property. However, in the many instances, what happened that there are a lot of other biomolecules, and those biomolecules can also affect on to these lactophilic platinum center, and then they can replace these water molecules with a labile or chloride molecule, and then form something stable species which is attached with the thiol group. You can see with the HSAB principle, the thiol can interact more strongly with the platinum as compared to chloride, so it cannot be replaced to bind with the guanine L7 position of DNA. So now this molecule of no use to bind the DNA, so this has to go out. So it it will be removed from the cell. So you can see the effective drug which is coming is now not effective anymore. So that's how one can get resistance, and one can get lower efficacy of the drug. So these are the few problems, and when you look at the overall limitations of cisplatin, these two categories which we can put is the resistance, which I mentioned in the previous slide, but why these drugs have problems, because as I said in the couple of previous slides, that this is the best drug from innovative side, which is competing with the paclitaxel even now in the clinical trials, but still it has a lot of problems, and those problems are resistance and metastasis. Okay, so resistance, what as I said, you can understand from the previous slide that cancer cells become resistant against platinum drugs, and they don't kill, even you pump more and more platinum into it, right? And another problem is metastasis. It means that somehow the signaling of cells will be in such a way that they will spread from one place to another place. So the tumor which is there in the lungs, that will go into brain, and then you will have some sort of different tumors in different places. Okay. And as I said that when you have tumor resistance, you will give more and more drug to kill the cancer cells, and those excess drug will create a lot of side effects, lethal for a person who is taking these medicines. So to tackle these problems, what we have taken challenges. So one of the challenges which I am going to discuss, that when we have a platinum therapeutics, can we make any regime which can overcome metastasis, right? We can also come up with chemo resistance and reduce side effects, which we are currently working. But today I am going to discuss about metastasis. So when we see the term metastasis and we try to see its molecular mechanism, and I'll just briefly discuss that. This is related with the inflammation. So inflammations are generally two types, chronic and acute inflammation. And in cancer, generally chronic inflammation is which is related, and this goes with a lot of biological process, and that ends up, inducing in cancer progression and metastasis. So if you can reduce the inflammation surrounding of the cancer area, one can actually achieve the reduction in the tumor metastasis. So if you reduce the inflammation, maybe we can reduce the cancer cells going from one place to another place. Okay. So with this hypothesis, we thought of a few key questions. So first one is, how does an anti-inflammatory drug alone answer its effect on the reduction of metastasis? That's what which I have previously showed, that aspirin, one of the drugs, and can we also reduce the progression of cancer? So that was the first question we thought. And the second question, whether we combine this anti-inflammatory drug with cisplatin and then reduce the metastasis and progression, because cisplatin can reduce the progression, obviously, and this anti-inflammatory drug can have both actions. Okay. So with this hypothesis, we looked at the literature and we found, yes, anti-inflammatory drugs have shown their effect in reducing the metastasis, because this is the general process by which the inflammatory molecules are being synthesized, right? And there is an enzyme called cyclooxygenases which contribute in forming these molecules, which are responsible for inflammation and inducing metastasis and tumor growth. So if we can take the non-steroid anti-inflammatory drugs, and one of them is aspirin, it can actually inhibit this enzyme cyclooxygenase, which is catalyzing the conversion of one of the molecule into another intermediate, which is responsible for the inflammation. Then, of course, we can actually reduce the inflammation, and thereby we can also reduce tumor growth or metastasis. So having this knowledge, we then searched what kind of anti-inflammatory drugs are available in the market, and we looked at, there are multiple drugs which are available, and one of the simple drugs which we have taken as a proof of principle, aspirin, and then we try to see if we can combine this and how we will utilize with platinum drugs. So the next question comes with us, the combination. So the combining anti-inflammatory drugs with cisplatin reduces metastasis and progression of cancer. Then we say yes. Unlike single agents, chemotherapy, combination therapy actually maximizes the therapeutic efficacy against individual targets, and it can certainly overcome resistance and just a minute. Yes. So, having this information, whether combining with anti-inflammatory drugs with cisplatin, it reduces metastasis and progression of cancer or not. So, we have this question, and then we could find the answer, yes, the single agents are not very effective, but when we combine all of them, you can have, you can overcome this resistance, as well as you can overcome the problem of cancer metastasis. All right. So now, having this knowledge, Another problem that we faced is that if we combine them, then how we combine? Whether we give physical mixture or we give as a different formulation. So when we are giving physical mixture, it means this physical mixture is going in different direction, because when it goes into the body, it can go into different places because of the difference in pharmacokinetics and biodistribution. So we will not be able to control where we want to deliver, right? So to tackle this problem, what we did is to devise the concept of prodrug, pro-platinum drugs, and I think many of you know the prodrug concept in simple organic molecule. But in platinum drug, the concept of prodrug was a little bit different. That you have a platinum in platinum 2 state, and I think many of you might be knowing this. And if you oxidize this molecule, it will convert into platinum 4 prodrug form, right? This is oxidation, and you can actually reduce this in the biological condition. You get this cisplatin, which is in the active form. So that was the concept of product formation. And now this X can be any therapeutic use you can add. So when it is converting from the product form to the active form, it will release these X molecule, and these X is also therapeutic. This can be like aspirin, and this is cisplatin, what you need to kill the cancer. So to having this knowledge, the genesis of first chemo anti-inflammatory platinum product which we have come up, and it was simple molecule which we have come up is that attaching the aspirin on the axial side of this octahedral molecule. So how we made it? This is like simple, coming from cisplatin and coming from aspirin. So this cisplatin, as I said, it can bind with the DNA guanine groups, and this aspirin can go and bind with the cyclooxy that you recall in the previous picture, and then it can inhibit that so the PV prostaglandins cannot be made, so you cannot have inflammatory molecules. And synthesis was very simple, as I said, that you can convert this aspirin, right, acetyl salicylic acid, into its anhydride while utilizing DCC and DCM at 0 degrees Celsius. And once you have this anhydride, you can directly react this anhydride with the dihydroxy platinum 4 molecule. And how you make this platinum 4 molecule? You just oxidize this cisplatin in presence of H2O2 at 75 degrees Celsius, and eventually what you get is dihydroxy platinum 4 molecule. Why I say platinum 4? Because now it is platinum 4 oxidation state. And now you just simply do the esterification reaction, and you can ask the question, why not 2 molecules? We tried, but we end up getting only 1, maybe because of some steric hindrance or some sort of overreactivity. So this molecule which we have published in long back. So what I am trying to show that once you make this molecule, we need to demonstrate that it indeed has the biological activity as an apocyte, right? It should bind with the DNA with its functional groups, and it should also release aspirin, and that aspirin should also show anti-inflammatory properties. So to demonstrate that, the first experiment what we did is we took this platin A molecule, which is having platinum 4 prodrug with aspirin, and we did one experiment where in the test tube actually you took the truncated version of DNA, just guanosine molecule, guanosine monophosphate, and you treat this platin A with some reducing agent like ascorbic acid, and then you react with phosphate, but you will see that it forms like what it forms in the DNA, platinum BD adduct, right? Platinum molecule, and this guanosine, so we call it as platinum BD adduct. And it should also release aspirin, and this aspirin eventually should convert into salicylic acid. So that's what it happens, and you can see this by mass spectrometric analysis that this is indeed proven that this kind of species is formed by isotopic peak pattern, platinum GZ adduct, and also by HPLC analysis we could show that indeed it is releasing the aspirin molecule, right? You can see this is second aspect, as I said, that if it is relieving aspirin, which is anti-inflammatory drug, then it should also show its anti-inflammatory effect. So to do that, we did experiment to check whether platin A is reducing tox enzyme or not. So for this, we did ELISA experiment, and we could see that platin A is inhibiting this enzyme, which is PG synthase, similar to aspirin, right? In two type of tox variant, tox 1 and tox 2. We could also see the molecules which are actually inflammatory cytokines, which are IL-6, TNF-alpha, and IL-10. These molecules will also reduce when you treat with platinum. So this is one type of effect where you can see the anti-inflammatory property of aspirin, right? So moving on, you can also see this anti-inflammatory effect in the cancer cells by immunohistochemistry. So what exactly it does it will check the expression of tox enzyme. So if it is inhibited, okay, so if it is inhibited, you will see very dull fluorescence. But if it is there, right, then you will not see the fluorescence. So if you can see this platin A is exactly working like aspirin, right, and cisplatin and aspirin. So it means the platin A, which has aspirin, is capable of reducing the activity of tox enzyme, having a capability what we have seen in the previous slide in inhibiting the inflammatory enzymes. Okay. Moving on, the second part of my talk is that we were successful in making this platinum prodrug. Now the time to think about how we can take this to the next level, which is like animal study, because it was showing the good activity. So the second task was making it more stable. Okay. So what we did is we took this on polymeric platform, and we took help of electrons, and I will show you the structures how we did it. And we put platinum on one side, and another side we put aspirin. The same molecular formula, but now it is covalently attached to the polymer backbone with the electrons. And then we end up making nice nanoparticles. So let us see the synthesis here, right? It was a bit challenging that how you can conjugate lot of aspirin molecule on the platform. So we utilize this click chemistry approach, which is recently awarded Nobel Prize. And you can see in this that how we have developed from one OH to have multiple OH, and these four OH utilized to form this ester linkase, where you can have four aspirin molecules attached to this dendron, right? And this dendron has alkyne end, and this alkyne end can be coupled with the polymer, which I will show you in a short. So this is like from the aspirin side, and from the platinum side, you can grow this by again oxidizing it, and then you make the linkase, which is acid linkase. So one side you have this acid group, and that acid group can eventually react with the any OH or any other NH2 side of the polymer. So you can conjugate that into the polymer in the covalent bond. So this is the synthesis of the polymer side, but you have developed this genus dual drug conjugated polymer. So we started with the polylactic acid, right? This is lactic acid group. So polylactic had reside in one side, and then you develop again chemistry, so you can actually attach more of platinum products, as I said. So we have reacted this molecule with succinic anhydride to get acid end, and this acid end was again coupled with the amide bond, and then we could have this molecule installed on this polymeric backbone, and then we can have three OH which are free, and they are available to react with any acid containing molecule by ester linkase. So before we did conjugated the platinum 4 molecules, what we did, we performed this click reaction. So you can attach this dendron, which is having 4 aspirin molecule, and then you can end up having a molecule which is having 3 OH on one side and aspirin containing dendron on the other side. Now you can do the final reaction, and this final reaction, as I said, we have done with a molecule called plugin 4, and this molecule which was actually having acid functionality, and you can simply do the acid and OH alcohol reaction. You can form ester the way we have done here, and we can end up attaching 3 of such platinum 4 species. So that's how we could install these 2 drugs which were there on one platform. Now, because we want to have them longer period of stability in the blood circulation, we want to make them nanoparticles. So that's what we put them into hydrophobic polymer, which is polymer 5, right? And then they are equivalently attached, so the release will be very slow. So this is like the pattern representation that you have aspirin on one side, 4 aspirin, this is dendron, this is polymer, and this polymer is hydrophobic in nature. And then you have another side, another dendron, which has 3 OH, which were well attached with the platinum. Okay, so that's how you have drug A and drug B, and you can tune that to have multiple such positions, because you can grow dendron in different methods. Now this polymer, which is having hydrophobic backbone, because you should assume that here this is a polymer, so this part will be more, and this is just in the end side, right? So this hydrophobic polymer, if you put with another hydrophobic polymer which is having also hydrophilic chain, so that's why this particular polymer is PLGA OH. So this is antiphilic polymer. So the moment you put this into water, it will assemble in such a way that hydrophobic part will be inside. So that's how you can see the core, right? And this core is having the platinum drugs and aspirin drug equivalently attached within this hydrophobic region, and then this hydrophilic peg part will be outside. So that's how you can make a stable nanoparticle, and this process called nanoprecipitation. So for the second step, what then we did, we have nanoparticles. Can we check whether these nanoparticles are suitable to go into the animals or not? So we check its immunogenic property, whether they create any reaction in the body, right? So for that we check a few cytokines which we check in general for inflammation. So this IL-6 and TNF-alpha, we could find that these nanoparticles which we have prepared, they show no reaction, right? As compared to if you give any reactive inflammatory induction. You can also see that these nanoparticles do go and sit in the cytoplasm. So that is one important feature we could find. So there are 2 aspects, that they are not reactive. The platform itself is not very reactive, right? Another thing, they can internalize in some sense inside the cells, so we can deliver these drugs. Okay. So then we check cytotoxicity, and we can see that the cytotoxicity was also okay, but it was not that great compared to their parent drugs, right? So this is platinum 4 prodrug, and this is platinum 4 prodrug with reducing agent, and then when you treat with this formulation, right? This formulation is just aspirin and platinum nanoparticle, and then with glutathione, you can see some reduction in the IC50 value, but this reduction is not that great what we wanted to have for in vivo study. Okay, but still we could see, yes, they are capable of reducing cellular growth, and they are also capable of reducing the inflammation, which we have seen in the case of test product. Okay. Now we have 2 problems which we wanted to tackle before we take it to the animal model, but we do not have targeted delivery approach yet, because these formulations, nanoparticles or prodrug, they can go in every cell line, right? There is no selectivity where they can be delivered. So can we change these two aspects before we move on to animal studies? So to tackle this, what we did is we looked at in the literature and then we found there is molecule called GLU, and it is basically pseudopeptide. And if you put this peptide with bipeptide structure onto PLGA, this polymer, and then you make the nanoparticle, then this will be outside, and then this can actually target PSMA positive cancer cells. And those who don't know, PSMA is one of the indicators for prostate cancer, and when prostate cancer is there, it gets overexpressed on the cell, eventually it comes to the blood, and that's how people can detect the prostate cancer in the early stage. So this PSMA, right, this is kind of protein, it is overexpressed on the cell surface, and this particular small pseudopeptide can interact with this PSMA protein, and when it is interacting, it allows it for selective influence. Okay, so that is one strategy we thought we can utilize, and the second strategy which we have utilized to increase the potency of platinum, what we did is we made another molecule which has 12 carbon here, and we call it as platinum 12, and this somehow had very good cytotoxic property. So now you have the same scaffold where 4 aspirins are attached, but on the other side, what we did is instead of platinum 4 where we have butyroplatin, we attach this 12 carbon acid, and that end up giving a molecule which we call it as aspirin 4 PLA platinum 12, and those 3 molecules, and that turns out to be highly potent in cancer cells. Okay, now we can make blended nanoparticles. We call it as blended because we are blending these two different polymers. One is PLGA PAP, right? This copolymer with GLU as a targeting group. You take 50% of this and you take 50% of this in the solution, right? And then you dump into water to have precipitation, and when you are stirring very fast, it will have tiny little precipitate, and you call it as nanoprecipitate. So all these hydrophobic side will be taking up this formulation, and then that molecule will be outside with this targeted group. So that was the formulation we prepared, and we characterized that it has suitable size, which actually generally acceptable to go inside the cells. It has suitable platinum drug loading and aspirin loading, and we looked at under the PM that nanoparticles are size what we wanted to have. We also looked at if we give stimulation, different stimulation, aspartate, sodium ascorbate, whether we are seeing the drug release or not. Okay, so all those emphasize that yes, our formulation is good enough in releasing the active drug component, and that drug component, if delivered in the right cell, can actually work as per our hypothesis. To prove that, what you have to do is you have to look at how it is being taken up by the cells in targeted manner. So what we did is we took 2 types of cell lines, one cell line which has no PSMA protein on the surface, so we call it as PSMA negative, and other ones are having PSMA. So if you use targeting ligand, right, this targeting nanoparticles, and you're using the formula where non-targeted nanoparticles where this GLU is not there, and then control cells. So if you look at these cells, right, there are 2 types of cells, PSMA negative and PSMA positive. In the targeted formulation, you could see lot of red fluorescence inside the cytoplasm. Right, this is cytoplasm, and inside the blue stain is the nucleus, and then there is another stain is also used, which is mitochondrial GFP. So you can see the mitochondria in the green color, and you could see that lot of red fluorescence is there, and which is actually more in case of targeted nanoparticle, and that too more in linked cells which are having lot of PSMA overexpressed on the cells as compared to the cells which has very less PSMA. Even though it goes in here, but the extent is very less. So it is going inside the cells selectively. That was proven, and also we have looked at the treatment is growing exponentially. Okay, but the treatment which is divided into two groups like non-targeted and targeted. So targeted is reduced significantly. The tumor is reduced significantly in case of targeted, but non-targeted initially reduced, but then eventually started moving back. Okay, so with this understanding, what I'm trying to tell you that by having this targeted formulation, we can reduce the tumor volume by many fold, and that can also be seen by different stains, and you can also see the tumor size. What we have taken as a picture, the targeted formulation indeed reduces the tumor volume. So in summary, what we have shown is the development of products, and subsequently these products were conjugated on polymeric platform to make the nanoparticles, and then it was not enough. We modified this product formulation, right, polymeric platform, to have better potentiality of the polymer, so we can make nanoformulation which can be more effective in the tumor, and that's what we have. I just showed you. With this, I would like to thank you, all of you, for your kind attention, and I hope you people can able to hear my talk and you will be able to ask some questions. Can you? Okay, thank you very much, all of you. And I think the hybrid mode is a little bit different than the normal mode. But I hope sometime I can come and explain more about it. Yeah, yeah. And if you guys have any question, please send me. I can send my email. Yeah, yeah. Yeah. No, I have to rush because we don't, many people might have not understood that. But, yeah. Thank you very much. Bye.
આમાં બોલજો હેલો હેલો માઇક ચેક 1 2 3 હાય હાય આવી ગયો હે અચ્છા લાઈવ માં કરે છે वही तो मैं बोल स्क्रीन बंद
Good evening, uh, respected invited guests, invited speakers, principal sir, and judges, and dear participants. We are going to uh, start our oral presentation offline. So uh, I invite first.
Sarika. What?
Just first participant for oral presentation offline, uh, Patel Sarika Ben Praveen Bhatt. As we have mentioned, time 15 minutes, but due to time span, so we will try to restrict to 10 minutes.
Okay, sir. Okay. Good evening to all my respected one who is present here. Today I am going to perform my oral presentation on the ultrasonic assist synthesis and optimization of 4H chromin 2-amino 4H chromin's derivative with its antimicrobial activity. Sorry, I forget myself, Sarika Patel. I am assistant professor in Ganpat University and my research work is going on under Dr. Hasid Fagani, sir. My research work is performed under the multi-component reaction. It is based on multi-component reaction after using the ultrasonic irradiation method. Generally, we know the multi-component reaction in which one or more than three substance which is mixing which together and finally the product is formed. This one a multi-component reaction molecule is based on the assemble, which is one converts the chemical step in one port by simply mixing the different types of the substance. Uh, Here why multi-component reaction is important because it is high efficiency and the potential techniques than before we was used. Multi-component synthesis is atom economy and step efficiency and also reduce the waste generation. Here I have using the ultrasonic irradiation method for synthesis this substance here. The principle of ultrasonic irradiation method is which is performed on the electrochemical signal generator send a burst of electrical energy to the piezoelectric crystal form and through this the transducer causing the crystal to vibrate and convert the electrical pulses into mechanical vibration. After that, the number of microbubbles is generated and the reaction is happen here and three substances convert into one final moiety.
Therapeutical use of the 4H chromin derivative here, the number of the therapeutical use HIV, antifungal, microbial, anti-inflammatory, anti-tuberculosis and anti-cancer also. Here I have doing the comparison between the ultrasonic process and conventional process. The difference between this one, the time consuming process in conventional, but in ultrasonic process, if we are seeing the reaction is complete within a 3 minute, and conventional process we have a see the 150 minutes after completing for the reaction. General procedure for the synthesis of these different types of the 2-amino 4-aryl 4H chromin derivative. Here the resorcinol, melanonitrile and different substitute of aldehyde reaction in the water with catalytic amount of morpholin, and morpholin which is irradiated by ultrasonic irradiation at room at 30 Celsius. After completion of the reaction, we will monitor by the periodically by the TLC. The reaction scheme of my method is resorcinol, melanonitrile and uh, different aldehyde, which is in the presence of the morpholin and water. Ultrasonic irradiation method happen, and 4H chromin moiety generated here. Different types of the derivative synthesized here. This is comparative study. Here just I have a mark on this product. Here we are seeing the in the 3 minute the yield of product is 98 percentages, and in conventional method I have seen after the 150 minute just 54 percentage of the yield gain. Physical property of synthesis of my number of derivative here. This is optimization method of only one compound. Here I have highlight 3-hydroxyphenyl 4H chromin 3-carbonitrile derivative. Here we are seeing the different solvent system, and after the using of the different time, the number of yield is here present. After solvent optimization study, in the presence of the water, if we are using only 3 minutes, then 98% is yield. If we are increase the time, then we are seeing here the number of yield is decreasing. Effect of the time also here mentioned here the in the presence of morpholin 5, 10, 15, 20, 25 and 30, the number of the product here the highest number of product in the 3 minutes 98 percentages. Characterization I have seen, I have a present here only one substance 3-hydroxyphenyl 4H chromin derivative. Here the H1 NMR data of this my synthesized compound. Here aromatic hydrogen, 7 number of aromatic hydrogen multiplet which is present in the range of this one. Chiral carbon is also one, singlet peak is we are seeing here, and OH is also singlet 8.22. This one is the mass spectra. I have got the mass spectra here 281 a molecular weight. Then the IR spectra of this one here also the OH phenolic stretching, and we are seeing here 3398 here centimeter inverse. Then COC stretching 10882 1205 here also we are seeing. This one is the C13 NMR spectra of this one. Spectral interpretation, which I have just shown here, the microbial property of this my synthesized compound. Here I have using diffusion, Bayer diffusion method for ZY determination. I have using here Staphylococcus aureus as a gram positive, Pseudomonas aeruginosa and Fusarium solani as a fungal. The result of my synthesized compound, synthesized derivative give here the highest number of activity which is given by the furfural, and which is a heteroaldehyde, and it is give the good activity in the S aureus gram positive, gram negative and Fusarium solani also. This is conclusion of my work, which is a green reaction. I have telling here this one is the green reaction, and this is less expensive and more readily accessible catalyst under the ultrasonic method. Thank you, sir.
speed is decreasing. What is the reason for that?
Sir, maybe happen that in this 3 minutes only the highest amount of product is happen, but when we are increasing the number of the time, then micro bubble is also means micro bubble is happen, but the product is decreasing throughoutly. I have seen, but the reason is behind this one. Maybe sir happen this more time than maybe substance is not reacted properly.
So that percival is giving the good activity all the micro.
Yes.
So what may be the reason for that? Try to find out whether you try to find out the reason anyway, or is there any proposal scheme or any proposal thinking or logic that may be given by you?
No, sir, actually not. I am thinking on that, but maybe it's possible because maybe furfural is a heteroaldehyde, and then those all this other aldehyde is the simple aldehyde.
Nice presentation, Saigan. Just one question. When you work with multi-components,
Yes.
for example, three components which you have shown,
Yes.
which one is more feasible? Three component or two component? It's a very general thing.
Yes.
You can answer.
Sir, three component is more feasible.
More feasible.
Sir,
Inoculation theory. Yes. If you can use that. Okay. Thank you.
thank you, sir.
Now we invite second participant, Dr. Pan. There is a 10 minutes for presentation. There will be bell at 8 minutes. So the at least warning bell. Warning bell will be at 8 minutes.
Good evening, all of you. Myself, Dr. Paras Patel, currently serving as an assistant professor at Chemistry Department of Indus University, Ahmedabad. Today, I will discuss about the thermophysical, or we can say the thermophysical, acoustical, spectral, and quantum propulsion study of intermolecular interaction patterns of alpha terpenols in the solvent systems, or we can say the solvent environment of crassors. As we know that if I talk about the particular alpha terpenol, it's a means it's having a widely application in our daily life as well as the pharmaceuticals because of having so many medicinal properties in this particular molecule. But the biggest challenge we are facing that when we extract this molecule from the plant, there is no ability of proper solvent system which can effectively separate from the mixture. Even we go for the even analysis through the many sophistical techniques, we face the challenge in the developing the method. And the third biggest challenge, as I said, that the having the medicinal property, because we have no any information about the affinity of particular molecule in when we put in particular in silico among the protein structures. So this work give the idea of understanding these molecules, so we can use this data whatever I will discuss. It can be applicable for the even extraction, because as I said, the demand is increasing, so we can make a more effective methods to be even to do the separation, even to for the analysis, or even we can use the potency of this molecule in the pharmaceuticals or even medicinal property. Here First of all, our task is to understand whether when we mix this compound with the different solvent system, here in the only have mentioned the Crassol system, the purpose is that means the when we put this molecule in such environment where the methyl aromatic ring and the OH group is there, how these molecules behave. So for primary understanding of their interactions, we have taken help of physical property like the densities, speed of sound, and from that physical primary physical property, we have calculated several secondary property. Here you can see, and the deviation and their partial, even infinite dilution partial properties and their apparent properties has been calculated. And once from this data, we also perform the quantum computation study by using density functional theory with the hybrid method B3LYP with the basic set of 631 plus GDP. And from confirming the some conclusions, we also go for the FTR analysis. Here is the graphical representation of summarized data of primary and secondary properties. The first one here, you can see the black line indicating the orthocrasal binary system. Red one is the meta and the blue one is the para. Here you can see that in the first property, that is the excess molar volume. When we mix these alpha terpinol with the ortho, meta, and paracrasol compound, here you see that there is a compressibility we are seeing over here, because you can see that there is a minus zero point 0.8 value is obtained in case of orthocrasol. So it clearly saying that when you mixing this compound with the orthocrasol, even in the all the crasol compounds, the media, or we can say solution sinks, or we can compress. And the reason behind that can be two reasons. That one can be the intermolecular interaction in terms of dipole-dipole or hydrogen bondings or such kind of electrostatic things, or another reason can be that the geometrical fitting. So first, from the data, we confirm that yes, these molecules are showing the interaction with the functional group present in the crassol. And to confirm these things, we have also calculated the excess partial molar volume at an infinite dilution level. So here you can see that the again minus value is we are observing in case of orthocrasol, that confirm this media is compressing when you are mixing these two components. And to confirm these things, we have also studied the deviation in the speed of sounds. Once as we confirm that its media is compressing, we pass the sound wave from the media, and we found that when we passing the sound wave from the media, the positive value we are observing in case of orthocrasol. Here, highest positive value is observed in case of ortho, then meta, and then para. Completely reverse things we are observed over here, and they confirm that when media is compressing, means media become the resident that facilitate the passing of sound wave. So confirm the overall conclusion from this secondary property calculated from the speed of sound. Similarly, axis molar isentropic compressibility also supporting same way here. The negative value observed. Similarly, even I have not shown data because of the time limit. Even axis infinite axis acoustical value is also supporting, because we are getting highly positive value. Similarly, you can see that we have also calculated some theoretical model of speed of sound like a Junji, Nomato, ideal free mixture, and even the FLT theories is also applied. So from that theories, we come to know that the ideal mixing relation suits the base. So in future, if suppose some researcher want to understand this behavior of this molecule, even at particular required concentration, so he or she need not to perform whole the experiment again. Only you just put your required concentration data, you will have immediately the value. So you have to go with that particular value or your required interactions, right? Here is the data. Here you can see that the SV value and BV value calculated using the Radley-Rosenberg-Mayer equation, positive value and negative value of BV clearly supporting the dipole-dipole type of interaction. Here you can see that even the expansibility, the value, the highest expansibility is, you can observe that in the orthocrasol. One thing is observed that when you increase the temperature from the 303.15 to 313.15, this interaction becomes the weakened. These are the optimized uh, structures. And from the earlier data, we come to know that okay, it's a strong kind of interaction. It is compressing at particular concentration. Based interaction is there. But to find out the, because our purpose is to find out the active sites of this molecule, so we can put this molecule for the even pharmaceutical purpose in when we go for the in silico study. So because as we know that I said that alpha terpene having the huge numbers of the medicinal property, So for direct going to pipeline process, we are generally following the in silico process. So the first thing required is the understanding of this molecule and finding the active sites. So the active to find the active sites, we optimize the several possible sites and come to means three base interaction sites. Here you can see this is the alpha terpineol. The first and second possible site based having the energy. It's these one, the interaction between this oxygen of the terpineol and these one 45 hydrogens of the cresol, and one is the 29 number of hydrogen and the 45 number of hydrogen attached with the hydroxyl groups of the cresol. Same way, only have mentioned with the cresol, same way meta and para studies is there. The third possible interaction is there when we found the geometry where the OH group is showing the interaction with the methyl group of this cresol and the aromatic means the hydrogen which is attached with the aromatic ring of this carbon showing the interactions. Now let's come to the energy. As I said, the sites. This is the 3D MESP and 2D ESPCM the data. Here you can see that the highest electron, sure, I'm summarizing. Here is the active site. You can see the electron density over here. This is the cut portion, which is the plan passing from 37, 11, 29. Similarly, this is the second order perturbation data. Here you can see that it is clearly showing that the dipole and the hydrogen bonding types of interaction are there, and it is oxygen is giving the electron density from the lone pair 1 and 2 at the highest energy is observing. At the lone pair number 2 is giving the higher energy, and you can see that the energy in form of 8.18 kilocalorie. Similarly, for the second interaction site, the MESP and 3D ESPCR model. Similarly, but one thing is there in this particular second possible interaction site, only the dipole kind of interaction there, because you can see, sir, the most of the we can say that the two-centered bond is giving electron density to two-centered anti-bonding in orbitals. This is the bond length and the charge. I will only talk about these two. You can see that when is this oxygen given electron density to 45 number of hydrogen, the electronic charge is reducing from minus 0.5 to minus 0.47. Similarly, bond length also supporting. Once electron density is moving from the bond becomes little bit shorter. The data is already there. To finally confirm, we have studied the theoretical as well as the experimental FTR data. Let me come to the particular summarized table of both the data. Here is uh, minus value. I am summarizing within 1 minute. Here is the minus value is there, sir. When you can see the shift value with respect to the pure alpha terpineol. As I earlier said that alpha terminal is gives electron density from the lone pair to the two-centered bond of anti-bonding kind of orbital. So once it is giving electron density to the particular different bonds, sir, eager electron density is decreasing. So once density is decreasing and we go for the FTR analysis, definitely redshift has to be observed. So that's why here you can see that all these bonds are showing the redshift. So that is confirming it is a hydrogen bonding kinds of there, and it is a dipole type of interaction is there. So active site, as I said, the when you put this molecule for the even pharmaceutical purpose in silico, these suggested two sites are the base active sites. So you can go for even bioinformatics where you can do the docking with the protein and you can study whatever property you want to study. So as I said, thank you for your time. So any question from your side is, I will be happy to answer your doubt.
Where would you use this system? So,
Okay, so that purpose, it is a part of our whole project in which we have already completed the study of the those molecules which having the bioactivity, and those most of those compounds are terpenes, terpenols, flavonoids, all these compounds. and we do such study in all the solvent system, because when we talk about the activity, it generally depend about the interaction between two functional groups. So we have completed already, only the one binary system is here mentioned. We already studied even the solvent element in which highly electronegative atoms. So for that purpose we do such things in a, halobenzene series, fluorochlorobromo, in even in the alcohol system, even in the benzene, toluene, metazolene, mesitylene. So we can get the idea that even in substitution is changing what kind of effect we are seeing on the active sides, and even non-polar kinds of solvent environment.
Any particular software you are using for computational study?
Yes, sir.
Which software?
Sir, for even optimization purpose, Gaussian 60 is used. But for our purpose is that we are right now, because these molecules having the even more than 160 electronic system, so DFT method has to be used. So for that optimization purpose, Gaussian. What, sir? Sir, for energy calculation, I've used the NVO2 version, which is already associated with the Gaussian 60. So second order perturbation energy was calculated using the natural bonding orbital analysis.
You have used the Gaussian software for the optimization of the structure and find out the interaction of the molecule with each other. So, and you were saying that this molecule can be applied for the pharmaceutical purposes. And have you studied into any particular disease?
Yes, sir. Actually, this work is I did PhD under the Professor Sangeeta Sharma ma'am, and she will giving the lecture in our yesterday means tomorrow's session. So we have already, because in Ayurveda they are suggesting these kinds of compound in form of essential oil. So even we are working, even we have signed our project and we sanctioned 23 lakhs from GS BTM. We are using such compound in the Alzheimer or Parkinson kinds of disease. So the acetylcholesterol and the beta amyloid activity is reduced, because generally when we go for the even medicinal, even a practitioner, they are suggesting n numbers of powder, right? Because they are not confirmed, because they only need that alpha terpenoid has to be there. So they are sending means they are prescribing the powder which is having the such amount of these things, because we are not knowing that what other molecules are coming with it. So that's why the most of parts will be covered in the tomorrow's session by my guide, Professor Sangeeta Sharma, and she will take the lecture, and rest of part will be discussed in the tomorrow's session, sir.
So the accurate correlation between your compound and any particular disease that can be perfectly studied by the molecular docking and molecular dynamics.
So if you give me 1 minute, I can show you that result, sir. If you permit me, I will take only 1 minute, sir. If you permit me, sir. That just I am summarizing in 1 minute, sir. The accuracy of this, because sometimes question comes in right, because this is calculated in the software. But sir, when I did the software calculation, I have calculated BSSCE, that is basic cell superposition error. Once molecule is occupied, a single point energy is achieved, and then I do means I compare this value with the ground state of energy and with the force constant. And if his force constant is not completable, you will have the imaginary frequency in the FTIR, right? So in my calculation, there is no imaginary frequency. And second thing, uh, suppose our OH group is presenting at 3408 centimeter inverse. In our calculated data, it is exactly 3405. Only plus or minus of a 2 centimeter inverse is observed, and that was even uncertainty of our instrument, right? So exactly force constant we have achieved. So that's why I can say that this is the only possible site. Even you will even you make this a solution, it will be there. Welcome, sir.
Next participant, Vipul Bharadai Kaudike. He will be present. Dr. K.V. Goswami. No. Dr. Trupti Barot. Patel Shweta Amichandai. I invite Patel Shweta Amichan. Copy offline 6. 6.
Good, good evening to all. Myself Sweta Patel from the Mehsana Urban Institute of Science, Ganpat University, Department of Chemistry. And my research guide name is Dr. Hasid Bagani sir. And here my topic is ultrasonic promoted optimized green synthesis of 1,4-dihydropyranose 2,3-C pyrazole based derivatives and its antimicrobial activities. हाँ છે content. છે content એવું તો ના પેનડ્રાઈવ માં છે.
I have learned a process for the preparation of 1 and 2 nitronaphthalene and separation of 1 and 2 nitronaphthalene by solvent and anti-solvent method and its colorimetric data. Why we select this 1 and 2 nitronaphthalene? Because the kinetic practicals using Ki. So Ki is very costly. Approximate every college using Ki in year one semester 2 to 3 lakhs rupees. Instead of Ki, we are using this 1 and 2 nitronaphthalene synthesis in our laboratory, local for local project. One is this particular thing, and second, colorimetry data easily predicted, identify easily. So this is the abstract. Several work has been done, but I have particularly nitration using concentrate HNO3 and H2SO4 electrophilic substitution reaction occur, and if we use the benzene, nitro benzene is done, but we are using naphthalene. I am using 1 and 2 nitronaphthalene. So two isomers occurs. 94 to 95% 1 nitronaphthalene and 2 nitronaphthalene is only 6%. So why we do this work? The reason is clear. My next. Okay. नीचे नहीं. Okay. This is a reaction. The naphthalene derivatives, colorless compound, its physical parameter, melting point 80 degree, molecular formula, exact mass, and molecular weight, elemental analysis. And here 1 nitronaphthalene and 2 nitrolaphthalene. We synthesize the nitronaphthalene derivative. This is the 1 nitronaphthalene. It made in 94%. So I have synthesized in my laboratory also. And it's 1 and 2 nitronaphthalene easily XRD data shows 1 and 2 nitronaphthalene easily separated. This is the XRD data of 1 and 2 nitronaphthalene. I go to next, sir. Experimental reagents. We are using a naphthalene derivatives. Naphthalene, 65% of nitric acid, 96% of sulfuric acid, hexane, ethyl acetate, and 99% ethanol for the using separation and taken reaction mass for TLC and other derivatives data. Synthesis of 1 and 2 nitronaphthalene. I am using the 5 gram of batch and dissolve in 250 ml RBF, 7.5 ml nitric acid, and 6 ml sulfuric acid. We are getting at 60 degree, only 60 degrees. Because why 60 degrees required? Because the 59 to 61 degrees is the 1 nitronaphthalene melting point. So this is the particular, 60 degrees is the perfect temperature for giving a 94 to 95% making a 1 nitronaphthalene. I have done the reaction monitoring by only 1 hours required for complies this reaction, and after cooling in 20 volume of water, uh, ice cold water, it gives the 1 and 2 nitronaphthalene 70 to 80% yield. So I next in future my I have done maximum yield at least 80 to 90% or 95% for 1 nitronaphthalene. This is the characteristic data, chemical and physical data, boiling points, melting points of this UV spectra data. This is the literature survey. It's insoluble in water. So why we select the pour the reaction mass in water. So this is because of the reason is this, and it is highly soluble. It's highly soluble in ethanol, diethyl ether, chloroform, carbon disulfide, benzene, pyridine, etc. This is the IR data 766 and 1340 and 1518 for nitro derivatives, 1 nitronaphthalene. Strong vibration band 766 is due to the out of plane bending of aromatic CH coupled with nitro bending, while the symmetric stretching of nitro CN appears at 1340 centimeter inverse. Strongest IR absorption 1518 centimeter inverse is due to the in-plane bending of aromatic CH of naphthalene ring stretching. Next. This is the my instrument. Instrument name is Equiptronics Digital Colorimeter Equiptron 650A. Filter paper use blue for 120 nanometer. I am using this filter paper. I have used the point 500-gram compound dissolved in 50 ml solution, and then 1 ml, 2 ml, 3 ml, and adding ethanol solvent to make 10 ml, 20 ml, 30 ml, 40 ml, and 50 ml. Then I will take the data of transmissions and absorptions according to and calculate the log T. This is the log T versus concentration versus log T of 1 nitronaphthalene. It shows if we given unknown compound, so we are particularly BSc and MSc students, we are doing this practical in bachelor or master's students, and time saving process and no hazardous chemical using in this method. So I have done this practical for our BSc and MSc for next generation and next futures.
This is easy practical. This is an instrument equitrons digital colorimeter EQ 650A filter paper blue 420 nanometer 0.10 because the 2-nitronephthalene is only 5 to 6%. So I have separated out and I have taken only 100 milligram in 10 ml and then 1 ml 1 ml dissolved in 9 ml ethanol or any other solvent acetonitrile and so it gives the beautiful result transmission 66%, 65%, 56%, 52% and 28% absorptions according to log T results. Then next, this is the plotting the graph concentration versus log T. It shows the if we given unknown compound in our students, so we will get the easily filter out our students according to this concentration. 1-nitronephthalene safety data. Safety precursor is most important because the benzene is carcinogenic and so I have measured, this is the group 3 carcinogenic animal study oral administration. There is a 50 ml and 50 ml females, 0.6 and 0.2% of 1-nitronephthalene purity. National Cancer Institute data, it is not problematic. So if we is using the benzene instead of 1-nitro or 2-nitronephthalene, there is no problem for this National Institute data. Next. Toxicity data also I mentioned. Tumor effects, there is no tumor effects or no side effects observed in the mice and administration of 1-nitronephthalene for 78-week dose of up to 0.2 percentage in the rat doses and up to 0.18 percentage of the diet of National Cancer Institute 1978. So this is an old molecule, but we utilize. In summary, a process for the preparation of 1 and 2 nitronephthalene were synthesized, separate, evaluated colorimetry data, naphthalene, 1 nitronephthalene and 2 nitronephthalene, 10, 20, 30, 40, 50 milligram shows the colorimetry accurately. The details of colorimeter data, product 1 and 2 nitronephthalene have been reported, established, confirmed product beyond the debug. Future work, the practical will be useful for our BSc and MSc students. The process is cost effective, time saving, accurate result, easy analysis method is developed. In future, we will take 1 and 2 naphthalene, UV data, HPLC, and so on, NMR and so on. Because the practical is useful to our BSc and MSc students, and this is timeless and time saving process and local for vocal promote to our instead of KI chemical kinetic synthesis, we are doing this in our practical exam also. So this is most important. Authors are thankful to Department of Chemistry, Municipal Arts and Urban Science College, Mehsana, for their laboratories and instrument faculty facility. Thank you very much. Any question? Sir, this is I have taken for patent, so I have not displayed here. So that's why I have mentioned solvent anti-solvent method because sigma Aldrich claim only 85% for 2 nitronephthalene. I have 99 or 100% pure naphthalene. I have, this is the 1 nitronephthalene. This is a mixture of 1 and 2 nitronephthalene. I have also. I have synthesis in my laboratory. Both. ઓર્ડર આપો હું તો એમ જ કહું છું ચોરવાનું શું કામ ઓર્ડર આપો એટલે ઓર્ડર શું કામ ઓર્ડર શું કામ સાહેબ અમારે તો યુવી ચાલુ કરી આલો ને અમારું કામ તો શું થાય યાર અમે તો આ વેચવા માટે જ આવ્યા છીએ ઓર્ડર આપો એ તો કમ્પાઉન્ડ જ થઈ ગયું આ યાર ચાલુ કરું ચાલુ કરી આપણે 180 નો લેફ્ટ ના લઈએ
Shall I start? Good evening to all. Myself Sweta Patel from the Department of Chemistry, Mehsana Urban Institute of Sciences, Ganpat University, and my research guide name is Dr. Hasit Wagani. Today I present the research work of ultrasound promoted optimized green synthesis of pyranopyrazole based derivatives and its antimicrobial activity. So first of all, the introduction of pyranopyrazole derivatives. So first of all, pyranopyrazole derivatives. In the pyranopyrazole moiety, 2 nitrogen is present and 1 oxygen is present. So the pyrano 2,3-C pyrazole are 5-membered pyrazole rings fused with the 6-membered pyran ring. Here you can see that the 4 isomers of the pyranopyrazole. One is the pyrano 3,4 pyrazole, then the pyrano 4,3 pyrazole, then the pyrano 3,2 pyrazole, then the pyrano 2,3 pyrazole. Here I am choosing the pyrano 2,3 pyrazole due to the biological activity. So this is a therapeutically importance of pyranopyrazole. So you can see that the pyrazole derivatives is the good biological active component, and here you can see that the Celecoxib is the anti-inflammatory drug. This is the first inflammatory drug, and in this inflammatory drug, pyrazole group is present. So this is the biological activity of the pyrazole derivatives. You can see that the anti-ulcer, antidepressant, anti-cancer, then the anti-inflammatory drugs are here. So this is a research scheme of my work. So first of all, I am using the 1.4 component reaction. You can see that the first is the derivatives of aldehydes, then the melanonitrile and malonic ester and hydrogen hydride. This is a 1.4 component reaction. These 4 component is react with the morpholine and the water using the ultrasound method, and we get the final product is the pyrano 2,3 pyrazole derivatives. Next, comparison of experimental process. You can see that in the ultrasound process, only 2 to 3 minute reaction is occur, and we get the good percentage of yield. And in the conventional process, for 6 hours the mixture was stirred at the room temperature. Then we get the less percentage of yield as compared to ultrasound process. So this is a mechanism of nanopyrazole. You can see that the first step is the Novengel condensation reaction, and the second step is the Michael type addition reaction is occur. These are the physical properties of pyranopyrazole. You can see that the total 11 derivatives of here, and we synthesize the total 11 derivatives of the pyranopyrazole derivatives. Next, optimization study of the synthesized derivatives. Here I am using the one derivatives. It is the 4-hydroxyphenyl 1,4-dihydropyrano 2,3-pyrazole 5-carbonitrile. Here you can see that the different I am using the different solvents, and here mention the time and they mention the percentage of yield. You can see that when we using the water as a solvent, as a green solvent, and time is the only 3 minutes, and percentage of yield is 98%. Then the effect of time, you can see that the water as a I am using the water as a solvent, and here time is 3, 5, 10, and 15 and 20 minutes. When the time is increased, so that the percentage of yield is decreased. Then the effect of amount of catalyst in the synthesis of these particular derivatives, you can see that when the amount of morpholine is increased, suppose 5 millimole, I am taking 5 millimole, so that the time is only 3 minutes, and we get the percentage of yield is 98%. So here the conclude of this optimization study, amount of morpholine is increased, so that the time is increased and the percentage of is decreased. Next, comparative study of the green synthesis and the conventional method. You can see that the suppose C1 compound is here. I am using the 4OH derivatives of the aldehyde. So the ultrasound method only time is 3 minutes. Then the percentage of yield is 98%, and in the conventional method time is 130 minutes, and the percentage of yield is only 55%. So you can see that the total 11 derivatives, you can see ultrasound method only 3 to 4 minutes, and the percentage of yield is 80 to 98%, and the conventional method minute is also increased, and then the percentage of yield is decreased as compared to ultrasound method. Then the characterization of synthesized compound. So here IR spectra of the synthesized compound C7. So you can see that the synthesized compound is here, and in this synthesized compound NH2 group is here and CN group is here. So you can see that the NH2 group primary amine stretching frequency is 300-316 and the 3236 centimeter inverse, and the CN nitrile frequency observed at the 2207 centimeter inverse. Also here NH secondary amine group is here, so that the frequency observed at the 3129 centimeter inverse. And also here the aromatic ring is here, so you can see that the CH aromatic ring, then the CH alkane here, alkane group is here. Then the carbon double bond carbon aromatic ring stretching frequency observed at the 1497. Also here carbon, oxygen and carbon ring is present, so that the carbon oxygen carbon ring stretching frequency observed at the 1013 and 124 centimeter 47 centimeter inverse. Next, this is a mass spectra of the synthesized compound. So here you can see that the synthesized compound is here, and this molecular weight is 321, and here you can see that the M plus 1 peak is here 322.2. Then the 1H NMR spectra of the synthesized compound. Here you can see that the synthesized compound structure is here, and here NH group is present, so that the NH number of proton is 1 and the multiplicity is also singlet, and the delta value is 11.61. Here all the chiral carbon is present, so you can see that the chiral carbon CH number of proton is 1 and the multiplicity is singlet, and the delta value is 4.01. Here also NH2 group is present, so that in the NH2 group number of proton is 2 and the multiplicity is singlet, and the delta value is 6.87 ppm. Then the 13C NMR spectra of the synthesized compound. So here you can see that the synthesized compound structure. Then here important is the C9. Here CN group is present. So you observe that the C9 116.39 delta value is here. Then the aromatic ring is present, so that you can see that the aromatic delta value is here. Next, the pharmacology of these synthesized compounds. So here I am done the antibacterial and antifungal activity of the synthesized compound. I am using the gram-positive bacteria Staphylococcus aureus and the gram-negative bacteria E. coli. Then the fungi is the Fusarium solani. This is a protocol of the concentration of these all antibacterial and antifungal activity. So in this activity, I am observed that the 250 mg per ml was considered as a moderate activity, and the 50 and 500 mg per ml was considered as the good activity, and the 1000 mg per ml was considered as the excellent activity as compared to the standard drug of chloramphenicol. Same like for the fungi, in the case of antifungal activity, 250 mg per ml was the considered as the moderate, then the 500 mg per ml was considered as the good activity, and then the 1000 mg per ml was the considered as the excellent activity as compared to fluconazole. So here we can using the for the antibacterial reference as the chloramphenicol, means standard drug is the chloramphenicol, and for the antifungal activity I am using the fluconazole for the standard drug. So these are result of zone of inhibition values of the newly synthesized compound. You can see that the 4Cl, 4NO2, 4OH, indole 3 carbaldehyde, then the furfural. These four, these five compounds are get the good result as compared to other. So as compared to fluconazole and chloramphenicol, also other synthesized compounds. So these are reference of my research work. Thank you. And I acknowledgement for the Mehsana Urban Institute of Sciences, Chemical Science Laboratory, and also thanks to Gujarat State Education Department for the SOD scheme. Thank you. Thank you, sir.
Now I invite next participants, Jamie and Shwari. Is it present? Next, Archana Ghosh.
Good evening, respectable dignitaries and one and all present here. My work is basically focused on using biodegradable polymers for drug delivery, especially oral drug delivery. And during this presentation, I will be focusing on preparation of this drug delivery system, its characterization, as well as in vitro study. Scientists are already claiming that the future of medical technology is going to be nanomedicines. And the onset of that has already begun. Engineered at molecular level, applied in monitoring, treating, and controlling biological systems with the help of nanoparticles makes this medical system entirely a personalized one. And that is why nanomedicines are very rightly called the right drug to the right patient at the right moment. And in nanomedicines, biodegradable polymers are widely sought after mainly because of their several advantages, such as improved biocompatibility. They help in easy permeation through tissues, and surface area is more, so binding sites are more. These are some of the well-known examples, advantages of these systems. And this work is focused on anti-diabetic medicines. The latest report suggests that at present there are about 382 million people suffering from diabetes, and by 2035 this is going to become 592 million people, which means 1 in 10 adults is going to be diagnosed with diabetes, which is in very near future. And currently there are about 7 classes of medicines available for treating diabetes. However, they do have um, certain problems associated with it, such as first pass metabolism is a major issue. Their bioavailability is very less. Also, the drug delivery is not being delivered in a controlled fashion. These are some of the issues that we are facing currently. So the aim of the present work is using biodegradable polymers to prepare a composite and encapsulating encapsulating anti-diabetic drug sitagliptin into it, and we are using a green cross-linker tetraethyl orthosilicate for this purpose. Um, as I said, we are using biodegradable polymers. The polymers were chosen very carefully. First, we have guar gum, which is a plant-based polysaccharide, and it is obtained from guar, which we use in our daily diet, a legume that we use in our daily diet. It is non-ionic in nature, and it is resistant to acid pH. Then we chose chitosan. It is a very versatile cationic polymer with good number of amino groups on its surface. It is having two important properties. One is mucoadhesiveness, and secondly, it helps in permeation through the tissues. Then we added polyvinyl alcohol, which is a biodegradable polymer, and most importantly, a nanofiller, that is montmorillonite clay, which was used as a nanofiller so that we could improve the mechanical stability of the entire composite that we were preparing. The entire process was optimized by changing multiple parameters, such as initially we changed the concentration of polymers. We tried to change the crosslinkers used. We also changed the amount of crosslinker used, the amount of nanofillers used. We also checked out what happens if we do not use crosslinker and what happens if we do not use clay. What happens if we do not use plasticizer? In this material, it was glycerol. And finally, we came up with an optimized formulation, F20, where finally we encapsulated the drug sitagliptin into it. So this is one possible mechanism how the composite might have formed. However, certain things are yet to be confirmed. Okay. Now, once it was formed, we use different characterization techniques such as IR, XRD, DSC, and SEM. I am not going much into detail since because of time. However, we can see that in all the characterization, we took 5 different composites because we were comparing. This was the entire work was focusing on what happens if there is absence of nanoclay, what happens if there is no plasticizer, what happens if there is no cross-linker. So the entire work was went on a comparative basis, and based on these characterization, DSC, and finally SEM, we came to a conclusion that the drug was well encapsulated within the prepared system. Um, Now, our aim was to take this delivery system for oral drug delivery. That is, when we take medicines through the mouth. One thing I would like to make clear here, when we take drug through the mouth, it goes through the mouth, through the alimentary canal, and our aim is that it should reach the intestine where maximum absorption of drug takes place. Before reaching intestine, the drug has to pass through stomach. The pH of stomach is about 1 to 2 pH, and in this place, most of the drugs cannot survive. They get released quickly, they get degraded. That is why bioavailability of many of the drugs goes down, and we have to take more dosage of these drugs. So that is why our main aim was to protect the drug in the stomach so that maximum drug went to the intestine. And for this, we did some swelling studies to analyze how this composite will work in the acidic pH and how it will work in. Now 7.4 is the pH of the intestine and 1.2 represents the pH of acid our stomach. So we found that when in the composite, when the amount of guar gum is more, it sustains well in acid. When the amount of chitosan polymer is more, it sustains well in the neutral pH. Then we went forward and checked what happens if we change the cross-linker. During optimization, we had used glutaraldehyde and formaldehyde along with our green cross-linker TEOS. Now, glutaraldehyde and formaldehyde are some of the common cross-linkers used in drug delivery. However, we found that TEOS shows a controlled swelling process in both the medium. Also, we wanted to avoid the other two cross-linkers because they show cytotoxic activity in the body, and hence we were sticking to the greener one. Then we also tried to change the amount of crosslinker, which did not have much influence. Mainly, we were now focused on what happens if we remove any of the component from it. That is nanofiller clay, the crosslinker, and the plasticizer. And we came to a conclusion that, okay, now here we can very clearly see that in the absence of crosslinker and the glycerol, the film is not able to survive in the system. Swelling is rapid, there is disintegration, and hence those system was neglected. And so finally, with this understanding, we went forward for in vitro drug analysis, where we studied the system in two fluids: simulated gastric fluid, which represents the fluid of our stomach; simulated intestinal fluid, which represents the environment of our intestine. And we found, here you can see the final composite that we had optimized. In the stomach media, less than 14% of drug is released, which means we could take maximum amount of drug to the intestine, and our objective was successful over here. And finally, we wanted to know what kind of release is taking place. So we used some mathematical models, and based on this, we understood that the drug was getting diffused out of the system. Diffusion was first phenomenon, followed by a sustained release. Now, one interesting thing which we found was this is where our drug is getting released. Now, here you can see there's a burst release of about 60 to 70%, followed by a sustained release. Whenever our sugar level shoots up, our immediate concern is we need to bring it down first, which is done over here. And once it is controlled, we have to maintain that sugar level, which means we need a sustained release system. And that is being followed over here. So what we were aiming for was achieved through this work. We further went for antimicrobial studies too, which gave fairly good results. So we were able to create a composite which could deliver drug to the intestine. And it is a very economically viable and green method. Finally, this is at in vitro level. Now we would take this work, we would like to take this work to in vivo in animal models. Also, sitagliptin is a drug which is given in combination therapy. So we would like to include one more drug, metformin, into it and see how it releases in combination way. I would like to thank MN Science College for giving us this opportunity where we could listen to eminent speakers today, and also giving an opportunity to present our work. I would sincerely thank my home department, Department of Chemistry, Gujarat University, for giving a platform to carry out this work. And I would especially thank my research supervisor for guiding me and giving me insightful thoughts during the entire work. Thank you so much.
Why you have chosen only the Kavargam, not any other polymer?
Sir, I have been working on multiple polymers, but in this case, my major concern was how to protect the drug in the acid medium. So we needed a polymer that can survive that acid medium. And there are very less polymers which can resist that.
Kavargam will form a gel.
Yes, sir.
During pH 1 to 2,
It forms a gel.
And the immobilization of this drug will be there.
Yes, sir. That is where the other components are playing their role. Govardhan is there, but we have restricted its movement.
Instead of that, if any sodium alginate or alginic acid, something, maybe.
Yes, sir. So may I, like, I have worked with sodium alginate also, but sir, the popular belief is that sodium alginate shrinks in acidic medium. Uh, but sir, exactly opposite is taking place, and this phenomenon, this contradictory phenomenon, has been reported years back. But in latest reports, they are saying it gets shrink, but actually it is not shrinking. The drugs are coming out of it. But about 20 years back, people who worked on it, they have reported, although theoretically it should shrink, practically it is not observed. And we saw the same thing.
But one thing I would like to suggest you
Sir,
that if you will use the psyllium seed husk instead of all these,
sir, which one?
psyllium seed husk,
Psyllium
then
seed.
it will be useful to the people if they are taking as a laxative. Then it will work.
Yes, sir, it is indeed. It should be given a try. Definitely.
Try.
Yes, sir, definitely.
Psyllium seed husk. It's up to you.
True. Yes, sir. Give it a try. Yes, sir. There are various other clays also. But sir, when we look at the toxicity, Montmorillonite is more preferred. The other ones, they are currently their application is increasing. Also, the stability provided by Montmorillonite is the highest. Its stability when it comes to its combination with chitosan is the maximum. Other clays do not give that much stable composite.
So you have purchased or collected from any?
Sir, I have purchased Montmorillonite.
Thank you.
Thank you, sir.
Thank you. We end here today's oral offline session. Uh, After that, there is a cultural evening at 6:30, and after that, dinner at assembly. Cultural evening, cultural event is at Assembly Hall, and then dinner. So I all to invite you to present there. Thank you very much. I am very thankful to both the judges, Dr. Santosh Kumar sir and Pranav Srivastav sir. Thank you, sir.
Hello, don't think so. Hah? Biasa mo ko na para bang. Aku tahu ke ke tahu ke bang. हाँ मु हाँ मुआई nyambline ke kadu. Apa tu? हाँ belum हाँ हाँ